Hey, hi friends. Sorry, I'm a little late, so let's get started. Uh, this lecture is on probability, continuation of permutation combination. Probably continuation in the sense what I meant is I'll use some of the concepts from permutation combination, but it's more about understanding of probability. A lot of people tend to think that if I know permutation combination, I know probability. Not really, because probability has its own elements. So one should understand what are the elements of probability, and of course, that's a primary focus of the lecture. So in addition to that, along with that, yes, of course, like so kind of you can say that half the job is done if you know your countings well, right? So that's what you learn in permutation combination. That's like with respect to probability, probably half the job is kind of done because we have done our permutation combination in the last two lectures of quantitative aptitude. So there we are. Let me introduce you to what are those elements basically that I'm going to discuss out here. So what are those couple of things? So let know, so maybe about a dozen odd things that I'm interested in discussing out here. So here are these elements. So if you look at it, so I would talk about the probability. Just give me a minute. Let me adjust the slide. Yeah. Okay, so I will talk about the definition and terms, of course. Maybe I'll not spend much time on that because basics of probability we all understand at this age. But I'll be talking about the application with respect to coins, dice, and cards. Maybe sometime I spend on that. I'll also introduce you to the applications thereby. And then we'll quickly look at each item, maybe one or two examples. That's a probability of union, the importance of at least one, which I already spoke to you in while doing the permutation combination. That's a point number 4. Then we'll talk about sometimes they make it biased, then how does it work? Then conditional probability, which is one of the important ones. So what's the significance of that? Then we'll talk about the binomial distribution of top-up probability, and so on and so on. Maybe some of the theorems towards the end, right? The base theorem, let's try and do all it towards then, maybe a couple of theorems, 0.78 or a couple of theorems there. So let's try and see how do we go about it. So this is what I'm going to discuss. Therefore, as I said, it has its own elements basically. Let's try and understand what is the basic terms one should know. What is the basic, what's a basic language that is going to be used. Therefore, what is that one should be kind of like one should be kind of familiar with. So here we go on the definition side. So we all know the definition. Probability of an event is nothing but number of favorable outcomes divided by total number of possible outcomes. If you let me help you to quickly recall from your high school or maybe college technically. So the definition wherever you read it first. So let me help you to understand. They would have taken some simple illustration, something like this. Say I have a dice. Right, I have a dice. If I roll this, or what are the outcomes on the dice? So when I roll a dice, the outcomes can be 1, 2, 3, 4, 5, 6. Now this is also called as a sample space. This is also called as a sample space. right? Yeah, we also call this as a sample space, right? Yeah, random experiment. What do you mean by random experiment? Because it's an unbiased dice. Anything may come out randomly, which means if you take a dice, rolling dice, so 6 numbers are there when you roll it. So any outcome is equally likely, right? No, so therefore we call it as a random experiment. Random experiment means what? You don't have a control, right? You don't have a control. So that's what we mean by the random experiment. So therefore, so sometimes you may come across a word random experiment somewhere, sample space, or will random experiment. Right? These are some of the words that you generally kind of keep hearing when you start reading about this particular chapter or solving some questions about this from this particular chapter. Now, events are what? Define something on this. All right, now, so let me define one particular event. Let me call it as event A. You got to define what is event A. Therefore, event A could be getting an odd number. Let's say that, okay, event A is getting an odd number. Event A could be getting an odd number. So which means what are the outcomes in favor of it? One is outcome, okay, or getting an odd number. Say, let's say 1, 3 and 5. Okay, what is event B? Let's define a couple of events. These are called events, just in case you would have forgotten. Hey, what was this event we were talking about? What is event B? Getting an even number. Say, let's call it as getting an even number. Getting an even number. All right, therefore, what are the favorable outcomes? 2 is favorable, 4 is favorable, 6 is favorable, likewise. Okay, you can define many more events. You may say that, oh, I'll define another event. See, what is that? Getting a multiple of 3. Alright, getting a multiple of 3. Likewise, you can define many multiple of what? 3. So therefore, what are the outcomes in favor of it? 3 and 6. You may say that, oh, I'll define prime number. Do whatever you want. There are many ways. Many events can be defined here. Right? Many events can be defined here. So for example, now if I ask you now here, what is the probability of event C? What is the probability of event C? So in a sense, say how many are in favor? There are two numbers which are in favor, that is 3 and 6. So that is what you mean by number of favorable outcomes. How many are in the favor? 2 are in its favor. Hey, what is the total number of outcomes? Here it can be 1, 2, 3, 4, 5 and 6. So therefore 2 out of 6. Therefore you say that 1 out of 3. That's a probability. Simply put, already you will say that number of favorable outcomes. So you got to understand what is that particular event. You got to understand sample size. Two things you need to understand. If I talk about probability of C, what is that you need to understand? What is this event C and what is my sample size? When I roll a dice, what is my sample space? All right, what is my sample size? So therefore, once you understand these two, your sample space is clear, your event is clear, you'll be able to write the probability. Correct? Yeah. So that's one. So now event A and B are also called as mutually exclusive. What do you mean by mutually exclusive? Number of outcomes in favor of A, number of outcomes are number of outcomes in favor of A intersection B is equal to 0. We call it as mutually exclusive. Okay, sometimes they use these words. Don't glorify these words. It is not that, okay, because some people will be too hassled about them. Oh, I need to understand this very meticulously. No, don't be hassled. You just understand that, okay, number of outcomes which is common to both is 0. That is called as, we simply say that these are called mutually exclusive events. All right, mutually exclusive events. Can I say that all right now A and all right, B and C are mutually exclusive? No, the event B and C are not mutually exclusive because 6 is common between the two. 6 is common between the two. Therefore, B and C are not mutually exclusive. Hey, can I say that A and C are mutually exclusive? No, because 3 is common to both. Right? They are not mutually exclusive. Therefore, in this case, if I ask you, are A and B mutually exclusive? Yes, mutually exclusive means number intersection is this. All right, yeah. And then collectively exhaustive. Sometimes we'll say that collectively exhaustive. See, some very rarely used words. Don't glorify them, as I told you, right? Yeah, just to be just to be aware. That's it. Because suddenly you get this as a part of some question, you got to be kind of aware as to what author is communicating to me, right? Collectively exhaustive, exhaustive. Collectively exhaustive means what? Number of elements in A union B should be equal to sample space. Alright, that should be equal to sample space. Is it true? Yes. Alright, now if you look at here, alright, A is giving an outcome of 135. So B has an outcome of 246. Now union, alright, if I take a union of both of them, am I getting my sample size back? Every single element of sample size, am I getting it? Yes. Okay, that's called as collectively as exhaustive. What if that A, B, C together are collectively exhaustive? Yes, that's also fine. Number of elements in A union B union C. That also gives you the sample size. You may say that 3 is duplication. Say Here, 3 is duplication, use it only one time. Or let you take it only one time. That's the meaning of union. You don't repeat the element, right? So therefore, that is what you mean by collectively exhaustive. 2 events, or it can be more than 2 events, but you use the word something called as the collectively exhaustive. All right. So now let me introduce another word. All right. Now, so independent events. Some events are said to be independent. Okay, I guess all right. Now this is a pretty definition. All right, in the sense I'm introducing you to what do you mean by sample space. What do you mean by random experiment? Just have a vague idea before we get onto the topic. Otherwise, we get onto the topic and suddenly we come across those words or start using those words. You think that, okay, what was this do? What is this doing out here? Okay, now what is independent event? All right, what is independent events? Events, because one event cannot be independent. All right, events. All right, therefore independent, all right, mutually exclusive events, because there cannot be one event which is mutually exclusive. Minimum two should be there, right? Yeah. So similarly, independent events. Independent events. Now say it's easy to explain this fact. Now let me assume that, okay, I have a dice. I have a dice. What is the sample size on a dice? Sample size on a dice. Sample size on a dice is 1, 2, 3, 4, 5, 6. 5, 6. Okay. Then I have a pack of cards. Then I have a pack of cards. Yeah, what is the sample size here? Of course, you have a pack of 52 cards, right? So you have a ace of diamonds, then you have a number 2 of diamonds, number 3 of diamonds. Likewise, how many cards you have? 52. Alright, how many cards you have in a pack? You have 52. If I define an event here, alright, now let me define event A. Alright, let me define an event called A. What is the event A? Event A is getting a prime number. Event A is getting a prime number. Event A is getting a prime number. Okay, now let me define here. All right, now event B. Event B I will define on this. What is event B? Getting an honors cards. All right, getting an honors cards. Honors. Getting an honors cards, right? Yeah, so if I define it like this, now A and B are said to be independent events. Independent, why? Because if our event A occurs, will it stop from occurring event B? Of course not. It cannot stop. If stop already it cannot, because when you randomly pick a card here, assume that, okay, you roll this particular dice and you pick one particular card. So event A occurred. Let's assume that. What is event A? You got a prime number. Does that mean that, okay, now you are not going to get an honors card? You will get an honors card. Why? Because these two are independent events. Pretty simple. That's it. So which means event A has no bearing on event B. Similarly, event B has no bearing on event A. All right, no, because these two events are defined on two different sample spaces at times. All right, no. So this is a simple way of understanding independent. So therefore, don't glorify these words. It's not about that, right? It's not about that. But however, all right, now here, see, if I say, I'll come to that probability later. What is the probability of independent events? We'll come to that particular part later. Okay, technically, let me explain it here only. Probability of A intersection B. If I ask you like this, probability of intersection B is probability of A into probability of B only if A and B are independent. Probability of A intersection B is nothing but probability of A into probability of B only when A and B are independent. Otherwise, what happens? That we will see in the conditional probability. Otherwise, what happens? It becomes conditional probability. That's it. Hey, what if A and B are not independent? Then conditional. Conditional, because there is some dependency. The dependency means that's a condition. So that we will think of it all when we go to conditional probability. This is true only when they are independent. Probability of A intersection B is equal to probability of A into probability of B when they are independent. We'll see the applications as we go along. What I did is I kind of introduced you to these words. All right, these words. Another word that you get is what? Complement of an event. Complement of an event. All right, in the sense of what are not in its favor. Complement is nothing but the outcomes which are not in its favor. So if I say that, okay, if I would have defined an event here, all right, now probability of C, all right, now event C is getting a multiple of 3. Let's say getting a multiple of 3. So what are in my favor in that case? All right, now 3 and 6 are in my favor. Therefore, complement of this particular event. What is the complement of C? All right, E C dash. Complement of this is nothing but 1 is in favor, 1 is not in favor, 2 is not in favor, 3 is here, therefore 4 is not in its favor, 5 is not in its favor, 6 is here. Therefore you say that the complement of the given event are nothing but 1, 2, 4, 6. Can I find the probability of the complement also? Of course, if you know how many elements are in favor of a complement, naturally you can find the probability of a complement. Okay, probability of an event and its complement, probability of an event and the probability of its complement is always total probability. is always total probability, which is 1. Total probability is 1 because either the event should happen or event should not happen. Event did not happen means what? Its complement has happened, right? So either event should occur or event should not occur. One of the two would happen there. So therefore the total probability is 1. Why 1? Because either it should occur or it should not occur. Where is the third choice there, right? Yeah. So that's that total probability is 1, which is very one of the important points. We'll come back to that. Okay, I think I gave a good 10 minutes introduction to this, background to this. Let's slowly make inroads into this. Let's start making inroads into this. Let's take questions based on coins. Questions based on coins. Do it alongside me. 5 coins are tossed together. Find the probability of getting 3 heads. Okay, 5 coins are tossed together. First, let's understand that. If I just toss one coin, if I toss one coin, first let's understand that what is the total outcomes. If I toss one coin, 2 outcomes. Hey, what is the 2 outcomes? Either it should be head or tail. What about second coin? 2 outcomes, head or tail. What about the third coin? 2 outcomes, that's head or tail. So therefore you will say that what are the total outcomes? Okay, let us take 2 only first. What are the total outcomes if 2 coins are tossed? 2 into 2, which is equal to 4. Or let 2 into 2, which is equal to 4. What is this 4? Like this. Or let coin 1 and coin 2, you may say that both are heads. Or you may say that one head and one tail. Then the point is the coin 1 head or coin 2 tail. Otherwise it can be coin 1 tail and coin 2 is head. Possible. The lastly, both are tails. These are the 4 outcomes. If you want to explain what are these 4, from where you wrote this 4. So these are the 4 outcomes there. Coin 1 has 2 outcomes. Coin 2 independent of coin 1. It does not depend on coin 1. Coin 2 also has its head and tail. So therefore all it 2. So what is the total outcomes 4? What do you mean? This is what I meant. This is what I meant. Right? Similarly, when 3 coins are tossed, there would be how many outcomes? 8 outcomes. All right, total number of outcomes would be 8. So if I toss coin 3 as well, there would be another 2 outcomes, head and tail. Yeah, what does it mean to us? C1, C2, C3. What are the 8 outcomes here? All 3 heads. Or you may say that no, yeah, 1 head and 2 tails. Possible. So in that case, C1 can be head, or C2 can be head and the other 2 are tails, or C3 can be head. C2 can be head and the other 2 are tails, or C3 can be head and the other 2 are tails, or there can be 2 heads, first and the second are head and the one of them is a tail. Or you may say that the second one is a tail and the other 2 are heads, or it might happen that the first one is a tail and the other 2 are heads. No, all 3 are tails. Alright, it is also possible that hang on, yeah, it is also possible that all 3 are tails. It's also possible that all 3 are tails. How many outcomes now? We have 8 outcomes. So therefore, this is what you mean, which means this is the first outcome, comma, second outcome, comma. Instead of writing all this, we'll say that 2 into 2 into 2. Look, there are 8 outcomes. Fine. Total is always easier. Similarly goes with the dice, my friends. There's a dice 1 and dice 2. How many outcomes? Dice 1 has 6 outcomes. Dice 2, 6 outcomes in its favor. Therefore, if you roll out dice 1 and dice 2, how many outcomes? 36. Right? How did you write in the schools? You wrote something like this. D1, D2, D1, D2. You would have written a couple of times, something like this. All of us would have written. Otherwise, they will not get marks. So then you will say that, okay, here D1, D2, you would have written 1, 1. All right, 1, 1. Then you would have written 1, 2. You would have written 1, 3, dot, 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 1, 6. Then it was started here 2, 1, 2, 2. Likewise, dot, 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 2, 6. Like this, you finally went on to write 6, 1. Likewise, 6, 6. So what is this grid trying to tell you here? 6 rows and 6 columns, 36. It's telling about the same number, 36, right? Yeah. Similarly, if I roll out 3 dice, what happens? 6 into 6 into 6, which becomes 216. Simple. I hope all of you are getting this point, what I'm trying to say. These are all I'm trying to help you to recall from what you did in the school, high school or college, whenever you did this. All right, now little bit of orientation you had to probability. I want you to quickly get it back in your mind, right? Otherwise, we will not be able to travel into the theorems, because we got to do certain theorems as well, which come in our management entrance exams. Fine. Okay. I guess all right. Now I helped you to recall sufficiently by now. By now you would have recalled much more than what I'm anticipating. Let's take a look. All right. Let's go ahead. Yeah, let's come to these questions now. Let's think a little better. Let's start getting into the depth. 5 coins are tossed together. Find the probability of getting 3 heads. First question, 3 heads. I want 3 heads. What is my denominator, friends? 2 power 5. If from where this 2 power 5 has come, there are 5 coins. C1, C2, C3, C4, C5. Therefore 2 into 2 into 2 into 2 into 2. What is this total number of outcomes? How many are in my favor? How many heads I want? 3 heads I want. Therefore 5C3. Hey, what is this 5C3? Any 3 coins can give the head, something like this. Already you have these coins C1, C2, C3, C4, 5, C5. How many heads you want? 3 heads. Okay, C1, C2 and C3 are given heads, other 2 are tails. Fine, that's okay for me. This is in my favor. This outcome is in my favor. You may say that no, yeah, alternate coins have given the heads. Okay, C1, C2, C3, C4, C1, C3, C5 have given the heads, the other two have given the tails. This outcome is also in favor of me. No, the C3, C4, C5 have given me the heads, the other two have given me tails. This is also in favor of me. Like this, how many you can write? 10. What is that 5C3 trying to do? It's saying that okay, 10 outcomes are in your favor. Totally how many outcomes you have? 32. 10 out of 32 is how much? 5 divided by 16. That's your answer there. 5 by 16. So if you say that 5 coins are tossed together, the probability of getting exactly 3 heads is nothing but 5 out of 16. All right, that is the chances. Great. Let's go to the second one now. At most 2 heads. What do you mean by at most 2 heads? Probability of getting 0 heads, or probability of getting 1 head, or probability of getting 2 heads. This is called as at most, maximum of 2 heads, right? Probability of 0, 1 or 2. Okay, so what is probability of getting 0 heads? Probability of getting 0 heads is what? 5C0. Just learn to write that. 5C0 divided by 2 power 5. What is probability of getting 1 head? 5C1, because any one coin, you have 5 coins there, any one coin can give the head. Fair enough. 5C1 divided by 2 power 5. What is the probability of getting 2? 5C2 divided by 2 power 5. Sure, you would have said that 2 power 5 is common. Can I quickly add 5C0, 5C1, 5C2? Perfect. All right, 5C0 is 1, 5C1 is 5, and 5C2 is 10. All right, therefore 16 divided by 32, half. Therefore you are saying that hey, this is half. Probability of this is half. This is 5 by 16. Right, the first is 5 by 16, the second one is half. Good. All right, take a look at the third one now. Let's take a look at the third one. Quick look at the third one. Quick look at the third one. At least 3 heads. What do you mean by the word at least 3 heads? I'm quickly introducing various words here as well. Right, at least 3 heads. What did we say? Probability of getting 3 heads, or probability of getting 4 heads. In fact, you can write 3H, 4H, etc. I'm just writing it 4 heads because heads can be in your mind. Right, a probability of 5 heads. What's the probability of 3 heads? 5C3 divided by 2 power 5. What is this? 5C4 divided by 2 power 5. This is 5C5 divided by 2 power 5. So therefore you would say that what is 5C3? 10, 5C4 5, and this, therefore you would say again this is 16 divided by 32. This is another half. This is another half. Okay, this is another half. Anyway, the point here is what I'm just quickly introducing you to few words there. Okay, let's take a look at the next one, friends. Let's take a look at the next one. I think you got a nice warm up out here with this coins question. One more on coins. One more on coins. I'll give a minute for you. Why don't you try it out? I'll give a minute for you. Why don't you try it out? Try it out. A minute's time for you. Yeah, good. All right. A coin is tossed 5 times. There is only one coin this time. Unlike earlier, there were 5 coins. This time, there is only one coin. A coin is tossed 5 times. Find the probability of getting 3 heads. Right? Probability of getting 3 heads. There is a single coin. So therefore, what I'll do? Coin is one. There is only one 1 rupee coin. Let's say coin is one, but you are tossing 5 times. First time when you tossed, what is the outcome? Second time, what is it? Third time, what is it? Fourth time, what is it? And fifth time, what is it? All right, now this is how I'll do. I'll record it. Assume that okay, sitting at your place, you are tossing a coin. You have 1 rupee coin in your pocket. You are tossing it 5 times. I can record. If you can tell me from the other end, I can record it here. First toss, what did you get? Second time, what did you get? Third time, what did you get? All right, now so there may be there may be several people listening to this particular lecture. You all know each one of you may say that okay, I got this first time, I got that second time. I can write your name of the first one. All right, now okay, you got all right now head, all right, tail, and then head, something like this. Okay, name of the second person. What do you get? I can record these numbers. All right, now so somebody said that I also got 3 heads, but I got the first 3 are heads. Then fourth time I got tail and tail. Now these are 2 different outcomes. 2 people have given me 2 different outcomes. Did both of them get 3 heads? Of course, yes. Both of them got 3 heads, but they got it differently. They got it differently because somebody got it in the third, fourth, and fifth trial. Somebody got it in the first, second, and third toss. Somebody may say I got in alternate tosses, 1, 3, and 5. Fair enough. So therefore, all it now very similar to the previous question. So my point here is what? Whether you toss one coin 5 times or one coin 5 times or 5 different coins, both are same. All right, the both are same. So either ways it is same. That's what I wanted you to understand here. So therefore, same question, same as the previous question. Therefore, you would say that a tosses here. There are 5 tosses where I should be writing heads. That's your choice, right? Wherever the 3 places. Therefore, 5C3 divided by 2 power 5. Because what is the outcome in the first toss? Head or tail? Two outcomes, head or tail. Second time when you toss, what are the possible total exhaustive outcomes? Two, head or tail, because something third outcome is not possible. Either it should be head or it should be tail. So therefore 5C3 by this, which is nothing but 5 divided by 16, just like a previous question. Previously what you did. Yeah, this is a nice trick question. Question B is a very tricky, nice question. Heads in exactly 3 consecutive tosses. Heads in exactly 3 consecutive tosses means what? I will write a couple of them for you. Right? Heads in exactly 3 consecutive tosses. You sometimes, all right, they twist the language. We need to be a little careful the way we use it. Heads in exactly 3 consecutive tosses means, okay, somebody said to me that, okay, I got the head, and head. I got a tail, and then I got a tail. I said that fine. Did you get exactly? Did you get heads in exactly 3 consecutive tosses? Of course, yes. T1, T2, T3. After that, he went on to get the tails. Assume that there is another fellow who said to me that, hey, I got head, and a tail, and a head. I said that yours also is fine. That's also in favor. Why? Because I want heads in exactly 3 consecutive. After that, the pattern should be broken. It broke in the fourth toss. The second person got the tail, and after that he got head. Fine, no problem. After that, head also is not a problem. Therefore, that's in the favor. The second one is in the favor. Assume that, okay, what if it happens something like, okay, the first one is a tail, and then I'm squeezing 3 heads and a tail. Okay, this is also fair enough. This is also fair enough. Exactly 3 heads are there. Exactly 3 heads. Exactly 3 heads. After that, the pattern has to be broken. Fine. So next one, what do we do? All it now. So we write 2 tails, and then last 3 are heads. That's possible. Or the first is head, the pattern broken, and the last 3 are heads. That's also fine. So that is it, guys. These are the only 5 outcomes. These are the only 5 outcomes. Again, the answer to this particular question is 5 are in your favor. 5 are in your favor. Totally how many? 2 power 5. Therefore, this time it is going to be 5 divided by 32. These are the only 5 outcomes which are in your favor, in which exactly 3 consecutive tosses result in a head. After that, the pattern would be broken. After that, the pattern is going to be broken. Something like that. Okay, so now thinking about this question, it's a pretty simple question, but they want you to think like this, because you cannot really put it as a permutation, etc., etc. out here. All that is not required. 5 coins is already large number of coins. Now don't try to make it all like now some big combinatorial question which has to be now taken so much time to solve. So where you will say that, hey, what if I toss 50 coins and ask a question? No, come on, 50 coins and ask a question, leave that question and come. Why you want to do it for 50 coins there? They should generally take 5 or 6 coins and ask such questions, which can be done like this, which can be thought properly, and then it can be resolved. That should not be an answer. That should not be a concern. Okay, this is another question. It's a beautiful question. It's one of the very good questions on the coins. Okay, let's go further. What did I do? I introduced you to coins. Let me quickly introduce you to dice now. Let me introduce you to dice. Let me introduce you to dice. Here is a question. A dice is rolled twice. What's the probability of getting a sum greater than 9? When you roll a dice, the sum greater than 9. How many times it is rolled? Twice. It is rolled twice. Therefore, D1 plus D2. Question is D1 plus D2 should be equal to a sum greater than 9. Alright, sum greater than 9 is what? 9 is fine. 10 is, 10 is fine. Greater than 9 is what? 10 is fine, 11 is fine, and 12 is fine, because the word is greater than 9. Greater than 9, 10 onwards. Therefore, question is what? Probability of getting 10 as the outcome, or probability of getting a sum of 11 as outcome, or probability of getting sum of 12 as outcome. Okay, so how many chances for 10? If I want 10, what can happen on the two dice 1 and dice 2? You may say that, hey, I got 4 here and then 6 here. Perfect. Or you may say that, no, yeah, I will get 6 here and 4 here. That's also fine, because 4 6 is different from 6 and 4, because dice is rolled twice. All right, the first roll of a dice. First time you roll, second time you roll, second time you roll. Did you get 4 first or 6 first? That's a question here. All right, did you get 4 first or 6 first? Because 4 and 6 adds up to 10, which we all know. But which one did you get first matters. Which one did you get first matters. Yeah, what if both are 5? That's fine. So now you cannot say that I will interchange this 5 also. No, you can't. Right? No, you can't. Okay, what about 11? All right, 11 is nothing but 5 6 or 6 5. All right, 5 6 or 6 5, because did you get 5 first or 6 first matters, because you rolled it twice. When you rolled it twice, there is an orderliness, because first roll is different from the second roll. Let's be mindful about it. See, that is where the counting that you learned in PNC has to be useful here. Okay, 12. Hey, what about 12? 6 and 6. Good. How many are in my favor? Therefore, all right, now there are 6 cases which are in my favor. Therefore, you are saying that 6 are in my favor. All right, probability of getting 10 or 11 or 12 is nothing but there are 6 cases in my favor. For each one of them, what is the denominator, my friends? All right, now 6 into 6, that is 6 square, because the first roll can give you any 6 outcomes. The second roll can give actually technically any 6 outcomes, which means there are 36 outcomes in total. Out of 36 outcomes, 6 are in your favor. Therefore, the answer is nothing but 1 by 6. Answer is nothing but 1 by 6. That's for the question 1. All right, first one. Or question A, that's the answer, 1 by 6. I hope everybody is following pretty simple discussion I'm doing here. Second one could be a good trick question. All right, second one could be a good trick question, provided if you roll 3 dice, it will become a fantastic question. Anyway, nevertheless, let's first take a look at this 2 dice when it is rolled twice. A greater number in the second throw when compared with the first, when compared with the third. What is the author is trying to say? Look, the number in the roll 1 should be less than the number in the roll 2. What do you mean here? So for example, in the roll 1, if you get 1, if you get 1 in the roll 1, then the outcomes in the roll 2 favor of outcomes which are in the favor in the roll 2 are 2 is fine, 3 is fine, 4 is fine, 5 is fine, 6 is fine. Okay, and what about I have 2 here? If I have 2 here, I can have 3 here, 4 here, 5 here, and 6 here. Likewise, say, what if I have 5 here? Or what if I have 5 here? 6. And what if I have 6 here? None. Or let's see, if you have 6 here, there is nothing that you can do, because you already got the best number in the first row. Can you get anything better than this? Of course you can't. Therefore, what you are saying, you got to add up these outcomes. There are 5 outcomes here, 4 outcomes here, and finally 1 outcome here. Summation 5. That's something that you are trying to do here. Good. So therefore, how do you mathematically, which means you already learned the fundamental principle of counting, how do you put it to perspective? Simple. You have the roll 1. The number in the roll 1 should be less than the number in the roll 2. Hey, what are the numbers in your favor, my friends? 1, 2, 3, 4, 5, and 6. All right, 5 and 6. Good. So what you want now? It's an inequality. Roll 1 should be less than roll 2, which means I want 2 numbers out of this. That is 6C2. 2 numbers. How many arrangements are possible once you select 2 numbers? Only one arrangement is possible. Say, for example, assume that you got 1 and 2. You selected 1 and 2 here. You should naturally write 1 here and 2 here. Yeah, what if I got the numbers 4 and 6? Fine. 4 you should write here. 6 you should write here, because that's a condition. Right? Therefore, what you are trying to say, 6C2, selections first and then arrangement according to condition, because you rolled it twice. So you need 2 distinct numbers, because it's an inequality, less than. So 6C2 is the selection. How many ways you can arrange? One way you can arrange. That's your answer. So instead of adding all this summation, you will say that 6C2 is my answer. Why? Because you are already aware of your permutations. Counting business, you know it by now. So because you know the counting business, you don't have to do it like a child. I will make a pattern and I will count. Fine. So when there is a very complex problem, I really don't know how to count. That's when you make a pattern. Not for such simple questions for which you can easily use NCR kind of thing. You will not make a pattern and waste your time. See why this question is coming. So let me extend. When a dice is rolled thrice, instead of twice, let me make it as thrice. When a dice is rolled thrice, what is the probability of getting? Let me add to this. What is the probability of getting? Now the first roll, the number in the first roll less than second, and the number in the second less than third. Now you can't keep writing the pattern. It's such a criminal waste of time if you keep writing the patterns now. Now the moment I got the third one, it's a clear test of your fundamentals. Are you getting the point here? Is now? So what the author is trying to question, right? So roll in the number in the first roll is should be less than the second one, which in turn should be less than the third one. Simple. Instead of saying that okay 6C2, you would have simply said that, man, the answer is 6C3. That's it. 633. Why? You got to select 3 numbers. For example, now you selected 3, 5 and 1. Let's say this is my selection. Fine. Then you better write 1 here, you better write 3 here, you better write 5 here. So therefore 6C3 into 1, instead of 6C2 into 1, it becomes 6C3 into 1. See, it becomes a lot easier. It becomes a lot easier to count. Otherwise you'll simply waste your time. Because you are not using your counting what you learned in the previous lectures effectively. So that's precisely the reason I said that it becomes 50% easier, provided you use it. You use them there. Okay, let's go further. Nevertheless, I hope everybody understood this. Let's go further. Okay, let's go to some of the application. We'll come back to cards after this. Okay, I'll give a minute here, guys. I think in one of the classes I spoke about these phrases being used here. Think about this. All of you think about this. Get me the response. Take a minute and get me the response. Yeah, beautiful question. Okay, so I told you, all right, let's first understand that A or B. What's the difference between, because your answer depends. All right, now let me, before even I get into this, let me first give you the background to this. What is the difference between A or B? A or B, either A or B, either A or B, because you keep seeing this in many instances, right? Now A or B, or you also find it as either A or B. So which means or is there here, all right, but there is a either or in the second case. All right, A or, all right, either, all right, A or B implies that at least one. A or B means at least one of the two things should happen. That is what you mean by A or B should happen, right? What do you mean by either A or B? Exactly one should happen. Let exactly one should happen. Say for example, if I make this matrix, let if I make this matrix AB. So tick means it happened. Assume that okay, we are expecting some things to happen between A and B. A qualified, B qualified. Already A qualified, B is not qualified. Say, alright, now this is what can happen. A and B, two kids have written something. At least one of them will be selected. Let's say A got selected, B is not selected. Alright, now, so what are the total outcomes that are possible if two people, alright, now, so the two people appear for some interview or whatever for a selection. A selected, B not selected. Okay, or B A not selected, B selected. Third one, both selected. Last one, both not selected. These are the total. So out of this particular total, if I say A or B, all it A or B, this is all it now this is in favor of A or B. This outcome is in favor of A or B. This is in favor of A or B. This is also in favor of A or B. Not this. This is not in favor. The last one is not in favor of A or B. Good. Okay. So on the other side, yeah, on the other side, first one is in favor of either A or B. This is in favor of either A or B. Second one is also in favor of either A or B. Second one is also in favor of either A or B. Here onwards, it is not in favor. This is not in its favor. This is not in its favor. So that's a difference. All right, that's what you mean by exactly one is selected, which means two of them are in its favor. If I say either A or B are in my favor. So when I say A or B, but I don't use the word either, just I use A or B, just like the first case, then there are three outcomes in my favor. That's a difference between these phrases. All right, that's a difference. Okay, I don't have to remind you to tell you about it, but yeah, I've seen enough and more of people all right making this kind of mistakes instead of which one to take when. All right, I understand that in logical reasoning, LR also they kind of make mistake because there will be selection problem. All right, now there will be selection problem. A or B is selected is different from saying either A or B is selected. But they kind of misunderstand it in a hurry. I don't know why they do that, but that happens. But otherwise, I'm sure all right, this is pretty much a high school grammar what I'm talking here. All right, now this would be clear from the high school. Maybe class 7, class 8 grammar what I'm talking here. Either A or B, or A or B is a class 7 or class 8 is the first time teachers will definitely now educate you about this. Fine, let's go further. Find the probability that a leap year chosen at random will have 53 Sundays or 53 Mondays. 53 now leap year chosen at random. Little bit of understanding of calendars is required here. Alright, in a calendar year, alright, now non-leap year. If it is a non-leap year, there would be 365 days. So what do you mean by leap year? Of course, we know that 366 days. We know that. Okay. What do you mean by 365 days? It is going to be 52 complete weeks. A week cycle. What is the cyclicity of a week? 7 days. And there is going to be one extra day because 52 into 7 is 364. 364 plus 1 is 365. Similarly, if I'm doing it here, there would be 52 complete weeks and 2 additional days. Now, these 2 additional days are 2 consecutive days, my friends. These are 2 consecutive days. You cannot say that, okay, 52 weeks are complete and then there are 2 extra days in a leap year. One of them is Monday, another one is Thursday. No. If one of them is Monday, the other one would be Tuesday or the Sunday. So it will be front or back. It should be 2 consecutive days there, right? Yeah, that's an important thing there. 2 consecutive days. That's a point here. So what author is saying is, look, I know that all in the given year, find the probability that a leap year chosen at random has 53 Sundays or 52 Mondays. Why? Author knows that, man, in a leap year, 52 Sundays are there for sure. 52 Sundays are there, 52 Mondays are there, 52 Tuesdays are there, and 52 Saturdays are there. Done. So what is the chances that there would be 53 Sundays? There would be 53 Sundays. Good. So now there are 2 extra days. There are 2 consecutive days, my friends. There are 2 consecutive days. What can be those 2 extra days? Those 2 extra days can be, extra day. There is extra day 1, extra day 1 and extra day 2. Alright, what are the chances for these 2 extra days? Let's simply analyze in a leap year. You said that there are 2 extra days. These 2 extra days are 2 consecutive days. It can happen that it's a Sunday, Monday, or it can be Monday, Tuesday, or it can be Wednesday or Tuesday. Let me write them. Wednesday, Saturday, Sunday. Now these are the seven pairs. These are the seven pairs. Now look at the first one, friends. First one is what? Simple or. Simple or means what? At least one. At least one. Either I need to have a Sunday, or I need to have a Monday, or I can have both of them. Therefore what? This is qualifies. This is fine. For A, question A, this is fine. Alright, for A, this is fine. This is fine. Alright, no, this is fine because both are there. This is fine because Monday is there. Okay, so this is not fine. 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 This is fine. Hey, why this is fine? Sunday is there. Therefore, how many are in my favor? 3 cases are in my favor. Out of how many cases, friends? 7 cases. Because you just have 7 cases. Think about them. How many lines did you write? First, second, third, fourth, fifth, sixth, and seventh. There are 7 pairs you can write. Out of 7 pairs, 3 are in your favor. Out of 7 pairs, 3 are in your favor. Okay, what about either or? Second one, either or means what? Exactly one. This is not in my favor because both are there. Sunday is also there, Monday is also there. Hey, either or means exactly one thing should be there. Both cannot be there. Therefore, the first one is ruled out. Second one is fine because only one is there. Second one is fine. This is ruled out because nothing is there. All right, now this is ruled out. The last one is fine. All right, because only one of them is there. So therefore, this is fine for B. There are 2 which are in the favor of B. 2 instances are in favor of B. Therefore, it is 2 by 7. I hope the point is simple. It's a pretty simple question, but it required 2 understanding. One, you should be very clear with A or B and either A or B. That is one. All right, that's number 1 I wanted to discuss with this particular question. Number 2, all right, number 2 here, a little bit of understanding about the leap year and non-leap year. Therefore, you should be clear about the concept of 1 odd day or 2 odd day kind of. Right, okay, that's a little bit about that, a little bit about either or kind of. Let's go further. Let's go further. Okay, I'll leave a minute for you here. I'll quickly leave a minute for you. Think about this. Just a minute. Think about this question. This we did in permutation combination 2. Concept we did in permutation combination 2. Close it. Okay, not all letters. Not all letters mean what? All right, what's the meaning of this language? Not all letters are placed, which means some are not placed, which implies that some are not placed. Okay, this is nothing but some letters are not placed. Some letters are not placed in the right envelope. Not all letters are placed in the right envelope means what? Some letters are not placed. Okay, 4 letters are there. There is a envelope 1, envelope 2, envelope 3, and envelope 4. Right, so how many ways solid letters can be posted? Technically, letter number 1 should go into this, letter 2, letter 3, and letter 4. Let's assume that this is how the letters should have technically gone. Alright, the first letter should go into envelope 1, second should go here, the third should go here, and the fourth should go here. Let's say that's what technically it is. But then what is the total ways? Alright, now somebody can post them total, so that one letter goes into one envelope, one letter should go into one envelope. 4 factorial. 4 factorial is the total. That's my denominator. 4 factorial, that is nothing but 24. All right, 4 factorial, 4 for total. What is the total number of ways of placing them, including the right way? First one is the correct way. This is correct. All right, the first way here you did is the correct. I will show you one of the incorrect ways. One of the incorrect ways can be letter 1, letter 2 are fine, letter 4 and letter 3 are interchanged. These 2 letters got interchanged. Now, is this wrong? Yes, because some letters are not placed in the right envelope. These are the 2 letters which are not placed in the right envelope. So 2, 3 like this. You can write 24th outcome. There are 24 such outcomes which are possible, right? Because 4 letters, 4 envelopes. So for how, what is the total here? Total is nothing but 4 factorial. Total is 4 factorial. How many are not in your favor? 23 are not in your favor. Only the first one. Alright, only the first one is the right way of doing it. Alright, now so not all letters are placed in the right envelope. Therefore, how many are in its favor? Not all. Not all are, which means 23 are wrong because only one is right. The first one is the only right one. So what about the remaining 23 here? Remaining 23 outcomes? They must be wrong. They must be wrong because there cannot be another duplication of this case. Alright, there cannot be one more duplication of this case. Therefore, everything is wrong. Therefore, the answer there is 23 by 24. Technically, if you say that, hey, what is the answer to the first two? What is the answer to the part A, that is 23 by 24. All right, that's answer to the first one. What about the B? No letter is placed in the corresponding envelopes. This will disqualify. This is also disqualify. Hey, why? Because already letter 1 is placed in the corresponding envelope. Letter 2 is also placed in corresponding envelopes. I don't want them. What is this here, friends? Dearrangement for 4 divided by dearrangement for 4 divided by 4 factorial. Hey, what is 4 factorial? That is total. Out of total, how many ways are there in which no letter is placed in the corresponding envelope? For example, all right, now what is that kind of case that I am talking about here? All right, what is that one kind of case? See, technically, letter 1 should go here, letter 2 should go here, letter 3 and letter 4. So one of the ways could be, all right, one of the ways that I am talking about could be letter 1 goes here, letter 4 goes here, letter 2 goes here, and letter 3 goes here. Now look at that. None of the letters have gone into the correctly addressed envelope. None of them here, none of them, not a single of them. I want something like this. How many such cases will be there? Dearrangement for 4. Therefore, required probability. Probability required is nothing but dearrangement for 4 divided by 4 factorial. What is dearrangement for 4? 9. 9 divided by 24. We can simplify this. All right, now this is 3 times 3, 8 times. Therefore, you would say that 3 by 8. All right, 3 by 8 is the outcome which is in your favor. Yeah, what is dearrangement for n, friends? So I told you in the last class, dearrangement for n is n factorial divided by 2 factorial minus n factorial divided by 3 factorial plus n factorial divided by 4 factorial. Likewise, plus minus n factorial by 5 factorial. Keep doing till the time you write n factorial by n factorial. Therefore, dearrangement for 4 is nothing but 4 factorial by 2 factorial minus 4 factorial by 3 factorial plus 4 factorial by 4 factorial. Stop. Don't write plus 4 factorial by 5 factorial. That becomes a fraction. Stop there. Stop there, which becomes 9. All right, which technically, all right, when you add up these cases, when you evaluate these cases, it becomes 9. Okay, let's go further. Let's go further. Circular arrangement, an application which is built on the circular arrangement. Circular arrangement, 30 seconds. Quickly think about it. It shouldn't take more than 30 seconds. A minute max. Yeah. Right. Okay. 10 children are seated around a round table. It's a round table. What's the probability that exactly 2 children sit between two particular children, A and B? Okay. So now, as I told you in that case, whenever there is an explicit restriction, first, first ensure that you deal with that explicit restriction. Where is the explicit restriction? With 2 kids, A and B. Assume that there are 10 kids, A, B, C, D, E, F, whatever. Now assume that there are 10 kids A, B, C, D up to J. There are 10 kids. Now limitation is on which kids? Limitation is on child A and child B. Therefore you will say that, guys, please you go and sit here. So fine, they'll go and sit. There are 10 chairs put around a circular table, let us say. There are 10 chairs kept there. 10 chairs are kept like this. So now first you can ask to A should go first or B should go. Does not matter. Let both of them walk simultaneously and then one of them settle down first. So now let's assume that, okay, A decided to sit first. A can sit in how many ways? One way. You sit wherever you want. Assume that A sat here. A sat here. A can sit anywhere he wants. Now assume that A sat here. Good. Because one way only. Where you sit on the circle, how does it matter to me? It does not matter. A can sit in one way. What about B, my friends? B can sit in two ways. What do you mean by two ways? Because there should be, now look at that, exactly 2 children sit between 2 particular children, A and B. A and B have some common sense. 2 children means what? B will naturally don't go and sit here. Right? B won't sit here. So B won't sit here means you don't arrange, you don't make sit B there. That's what I meant. B don't go and sit there. So you don't sit B there because it's clearly given there are 2 children, exactly 2 children sit between 2 particular children called A and B. Fine. So therefore you leave this blank. You leave this blank and then you will say that B will settle down here, or all right, now you leave this blank. All right, this place is blank, this place is blank, therefore B can settle down here. So therefore there are 2 possible positions for B, 2 possible positions for B. So therefore you say that B can sit in 2 ways. All right, B can sit in 2 ways. A can sit in one way. because A went first, A can sit in one way, he creates a reference. Once A sits, B counts two places, and then B can sit in two ways. Alright, now B can sit in two ways. Fair enough. Alright, now so out of two ways, somewhere he should sit, right? Okay, chalo, let's understand that he sat it here. Alright, he sat here, B sat there. Alright, now because he left two gaps, so any side he can leave, two ways are there. So for reference, I've shown it here. Now look at that. How many more people are left here, friends? 8 people. How many more people are left here? 8 people. How many chairs are there? 8 chairs are there. Therefore, 8 people go and sit in how many ways? 8 factorial ways, not 8 minus 1 factorial. Already reference has been created by A. Already A went on and created a reference. You don't need further reference. Simple. Alright, now therefore you say that, hey, your numerator, alright, favorable cases are A sat in one way, B sat in two way, remaining 8 people went and sat in 8 factorial ways. Simple, that's it. Divided by, hey, 10 people are there, 10 people, 10 children around a circular table, how many ways they can sit? If no restriction saying that between A and B, 2 fellows should sit, nothing is given. Kids, please go and sit. How many ways they will sit? 10 minus 1 factorial, that's a total. Alright, 10 minus 1 factorial, that's a total. So therefore evaluate this 2 into 8 factorial divided by 9 factorial. 10 minus 1 is this, nothing but 2 into 8 factorial divided by 9 times of 8 factorial. 9 factorial can be written as 9 times of 8 factorial. Cancel. Therefore the required answer is 2 by 9. Alright, therefore the required answer is 2 by 9. Simple question, very simple question. Okay, what I meant is I don't want to do too many questions like this. What I meant is they can create any typical question. They can create even much more difficult questions than this. But the point here is what? If I'm comfortable with circular arrangement, I would have closed it. Likewise, whatever you learned in permutation combination, all those 10 different things I taught you in permutation combinations, I can create questions built on that, applications built on that. Favorable divided by total. What happens in a favorable? There will be a restriction. Total, what happens? There won't be a restriction, right? There would be no restriction while you are writing the total. Exhaustive case, what you write in the total. Okay, I don't do too many questions. I just made it a point that, okay, we learned dearrangement. Therefore, all it we did a question on dearrangement because we learned a dearrangement. Therefore, here we came and did a question on dearrangement as well. Dearrangement was sitting in the numerator. So we did circular arrangement all it now while doing the permutation. Therefore, we came back and did something on the circular arrangement here. Likewise, all it whatever we learned there, we can capitalize on that. Okay, let's go further. Let's take a look at this now. So in probability, all right, now let's take a look. First, read this question. Take 30 seconds, read this question. I'll explain. Okay. All right, you might have read. See, so Alan, what is the chances of Alan getting selected? 1 by 3. All right, 1 by 3, 33%. What is the chance of Bill getting selected? About 20%. Find the probability that one of them will be selected. All right, the one of them will be selected. Probability of Alan getting selected or probability of Bill getting selected. Probability of Bill getting selected. If you do this question, okay, probability of Alan getting selected is 1 by 3. Probability of Bill getting selected is 1 by 5. And then all you just add them up and you will say that, okay, therefore this is going to be 8 by 15. Answer would be wrong. Answer would be wrong. This common mistake people do. This is a common mistake people do. There are two fellows here. Both of them appeared. Alan and Bill, both of them appeared for the selection process. And finally, we want only one of them to be selected. What you should do here? Alan got selected. And Bill did not get selected. Listen, that's important there. All right, that's important there because if you write this piece of information, this has gone wrong. All right, this piece of information has gone wrong. What is the actual way of writing it here? So this is little bit mindful about. So I know this comes very naturally to you, but sometimes in a hurry, all right, now you may do this as well, which would be wrong. If I do only that, then it is wrong. So what we should do technically here, Alan got selected. Always ensure that it's complete. Why? Because both of them appeared. Then consider both of them and write the probability. Don't write for one at a time as if the other fellow is not there in the contention. Consider both and write. Right? Alan got selected, but Bill is not selected. Alan is selected, but not Bill. Or Bill is selected, but not Alan. But Bill. Not Alan, but Bill. That is also fine. All right, that is also fine. So you got to write the corresponding number. Hey, what's the probability of Alan getting selected? 1 by 3. What is the probability of Bill getting rejected? What is the probability of Bill getting rejected? 4 by 5. Now look at this. This is what is the probability of Alan getting selected. Given to me. Probability of Alan getting selected is 1 by 3. Therefore, what is probability of Alan not getting selected? 2 by 3 because I said that the total probability is 1. Total probability is 1. Getting selected is 1 by 3. Therefore, getting rejected is 2 by 3. Similarly, it goes for Bill as well. Probability of Bill getting selected 1 by 5. Therefore, Bill not getting selected 4 by 5. Okay, therefore I need to be writing that mindfully. Okay, so now Alan not getting selected 2 by 3. 2 by 3. Bill getting selected 1 by 5. So that becomes my final answer. In the sense, it becomes 4 by 5 plus 2, sorry, 4 by 15. 4 by 15 plus 2 by 15. Technically, it becomes 6 by 15, not 8 by 15. If you do in isolation, it becomes 8 by 15. Correct answer is what? 6 by 15. Right answer is going to be 6 by 15. That is something you need to be little mindful about. So you need to consider both of them. Alright, you need to consider both of them. Only one got selected means the other fellow got rejected. That you need to consider. Some small point there. Okay, let's come here. Probability of union. Probability of union, let me explain this phrase first, even before you read this question. What is probability of union? That is number of elements in A union B kind of stuff. What is number of elements in A union B? Number of elements in favor of A, number of elements in favor of B, minus number of elements in favor of both, because this would be double counted. Therefore, you will reject this. All right, number of elements in favor of both. Why? Because all right, when you counted number of elements in favor of A, that time B or some elements which A intersection B also would have got connected there. So therefore, because it is selected twice, it is included here, also here. Therefore, you are rejecting it one time here. You are coming back and subtracting it once. Okay, anyway, I don't have to explain that set theory part too much there. We all know this. It's very familiar to us. This is very familiar to us. So probability means what? Divide this by total. Because you wrote the favor of A, favor to A divided by total becomes what? Probability of A. Number of elements in favor of B divided by total becomes what? Probability of B. Therefore, divide throughout left hand side and right hand side by T. It becomes what? All it becomes all it, then it becomes the probability. You are now trying to say that therefore this is probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, it's a very familiar one. I don't want to do too many questions built on this because we kind of know about this. Let me give another background before you solve this particular question. Let me quickly give one more background to this. Let me give one more background to this before you solve this particular question. The second background is this. The second background on this is the second one. So let me quickly introduce to cards. Just in case, now you are kind of not familiar to cards, playing cards. A deck of cards are nothing but 52 in number. So primarily they have been primarily they have been they've been classified as either the red cards or black cards. Alright, some cards are red and black. So if you are not understanding what is red and black, there will be some symbols written in black color and some symbols written in red color. Red cards and black cards, we call them. Take a pack of cards. It always helps. You can just take a look at them. You don't have to learn any play, etc. there, but you can take a look there so that you can connect with the questions on cards well, just in case it comes. Once in a while, the questions on card do come in the papers. So therefore, the connect becomes faster. Okay, red cards. Now the red cards are further classified as what? The red cards can be either, or the red cards can be diamonds, 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 or hearts. Okay, firstly, how many red cards are there? 26. How many black cards are there? 26. Both are 26 each. This 52 is equally divided into 56 each. Similarly, how many diamond cards are there? 13. Because now you are at this 26. So therefore 13 each. There are 13 diamonds and 13 hearts. What about the black cards? Alright, what about the black cards? Black cards are divided as spades and clubs. Spades. There are 13 spades and there are 13 clubs. Right? Yeah. So now if you look at each configuration of 13, let me just explain for clubs. There are two types. One, the honors cards. There are honors cards and there are numbered cards. Honors cards and numbered cards. Number. There is a number written on that. Hey, what are the honors cards? Honors cards are 4 in number. There are 4 honors cards. Out of 13 cards, there are 4 honors cards and 9 numbered cards. 4 honors cards and 9 numbered cards. Which are the honors cards? What are the names? We call them as ace. Then we have a jack. Then we have a king and we have a queen. We have a queen. Okay, what are the numbers cards? The number 2 onwards, 2, 3, 4 up to 10. These are the numbers you find written on the cards. Therefore, if I technically ask you that, okay, how many honors cards are there in a pack of cards? In a complete pack of cards, how many honors cards are there? 4 under clubs. Alright, then what do you say? You'll say that, okay, there are 4 honors cards under clubs. Alright, you would say that there are 4. One second, guys. All right, there are 4 honors cards under clubs, there are 4 under spades, there are 4 under hearts, and there are 4 under diamonds. Therefore, 4 into 4, nothing but 16. Therefore, if I say the total honors cards are nothing but 16. If I ask you that, hey, how many 10 numbered cards are there? How many cards on which 10 is printed? Again, 4. Why? Because one card is there under clubs, one under spades, one under hearts, and one under diamonds. I hope all of you, it made sense to you. Now, Jack, all right, now, so Jack, King, and Queen are also called as face cards. They are also called as face cards because you see kind of a face. Solid Jack, King, Queen, you kind of see a face there. Therefore, they're also called as face cards. Quick question to you: how many face cards are there in a pack of cards? How many face cards are there in a pack of cards? Good, 4 into 3, 12. Because in one suit you have, these are called suits. Club, spade, diamond, hearts are called as suits. In one suit you have 3 numbers, therefore 4 into 3 you have 12 numbers. Perfect. All right, now this is something that you got to keep it in mind. Let's now go back to the question. That's a kind of 2 quick backgrounds required for this question. Right? Yeah, this is very similar to set theory. This is very similar to set theory, which you know very well, which would be very familiar. Second thing is you need to understand a little bit about the cards. Yeah, good. Let's go to the question, friends. Let's go to the questions. Let's go to questions. First one. Let's go to the first question. If 2 cards are selected, okay, let's read the question first. If 2 cards are selected at random from a well shuffled pack of cards, how many? 2. All right, well shuffled pack of cards. What is the probability that both are of the same suit? Both the cards are of the same suit. So which means what? All right, no, probability that both of them belong to hearts. 2 hearts you got, or 2 clubs. All right, now, or probability of getting 2, all right, 2 diamonds, or probability of getting 2 spades, or probability of getting 2 clubs. It's or. So what is the probability of getting 2 hearts? All right, now how many hearts are there? First of all, 13 hearts are there here. How many hearts do I have? 13 hearts are there. So therefore 13C2, any 2 can come in. What is the denominator, friends? 52C2. Because when you pluck any 2 cards, any 2 out of 52 can come. But what is in your favor? As long as it is a part of this 13, that is in your favor. 13C2 divided by 15C2. Okay, so here also you will write 13C2 divided by 15C2. Why? Because number of diamonds are also 13. So therefore you can say that how many times I should be writing this? 4 times. 4 times, because first time, second time, third time, fourth time, all 4 times you would be writing the same number. Therefore you can say that it is 4 times of this particular number, not raised to power 4, into 4. All right, into 4. 12C3 divided by 50C2, 52C2, 4 times. 4 times you are writing the same number. All right, which becomes your answer. Therefore, I can write this as 4 times of 13C2 divided by 52C2. Okay, you can do that calculation. We already did enough calculations on combinations. You would have done a lot of assignments as well. So therefore, that should not be a difficult one to calculate. So if I know what to write, all right, then I will get the right calculation and right answer thereby. Okay, let's go to the second question, friends. Let's go to the second question. Both are diamonds or both are honest. Now look at the question. Both are diamonds or both are going to be honest. First, let's understand that. All right, what is the probability of getting, all right, how many diamonds are there? Diamonds. How many diamonds are there? 13. Number of diamonds are 13. Good. How many honors are there? All right, now honors. Number of honors cards are 4 into 3. All right, 4 into 4. 16 honors cards are there. 16 honors card. Why? Each suit has 4 honors card. Here, I told you that each suit has 4 honors cards. Each suit has 4 honors card, and there are 4 such suits. Therefore, 4 into 4, 16. Then, all right, then we say that, okay, how many diamond as well as honors cards are there? Double counting. It is in the diamond as well as in the honors. Right, diamond and honors, there are 4 cards here. There are 4 honors cards under diamonds. There are 4 honors card under diamonds as well, because there are 4 cards. Therefore you would say that these 4 cards are counted under honors cards also. These 4 cards are counted under diamond cards also. Now this is where you are saying, if you say that, okay, this is probability of A is nothing but probability of getting a diamond card. Let's say this is probability of getting a honors card. Therefore mine is probability of diamond as well as honors. That is what you mean by probability of getting a diamond card or a honors card. All right, that's where it fits in. That probability of getting a diamond card or a honors card is nothing but probability of getting a diamond card plus probability of getting an honors card minus probability of diamond as well as honors card, which means it's a diamond as well as honors, because these 4 are double counted, right? Therefore you are coming back and subtracting. That's technically the set theory is all about that, isn't it? Set theory is all about that. Okay, what is probability of getting a diamond card? 13C2. because you are picking two cards. All right, now both the cards, both are diamond cards, right? Yeah, 13C2 divided by 52C2. Okay, what about the honors card? 16C2, because there are 16 honors card. Therefore, 16C2 divided by 52C2 minus. What is the common here? 4. 4C2 divided by 52C2. Okay, 52C2 is the common denominator. You just have to get the values of 13C2, 16C2 and 4C2 and work with this particular equation there. That becomes your answer. All right, this becomes your answer for the second question. All right, second question. Okay, my point here is it is not about calculation. My point here is, hey, what is the probability of union? How do I understand the probability of union? Very simple. Just like you understand the probability in the set theory. So just like you understand the union in the set theory, same formula, use it here and finish the problem. Okay, good. Okay, that's about it. That's about the probability of union. So I'm not going to take too many examples because it's far more elementary and we know it very, very well. Very, very well. If required, I will talk more about this union when I do the set theory. When I do the set theory, I will try and spend little more time on that union. Okay, for now, all right, now let's move further. For now, let's move further. Okay, here we go. The next element. Next element. Yeah, we will learn a couple of things here. You think about it for a minute. There are beautifully 4 questions created there. This makes your concepts crystal clear. Then we'll go to the next elements. Yes, guys, think about it for a minute. How these 4 questions are different. The approach, the way you approach these 4 questions are different. Okay, do it with me. Okay, there is a box which contains 2 white, 3 black and 5 red marbles. Altogether 10 marbles. Technically, we put together 10 marbles. You have 10 marbles. Yeah. Now, if 3 marbles are drawn out at random, find the probability that each one of them is of different color. So, how do I do the A part? Now look at the way I'm writing it. This is how you also would have done. There is nothing wrong about it, right? Yeah. So 3. Now, so each one of them is of a different color. White. What do you write? 2C1. What is it for? White. Because each one of them is of a different color. What do you write? 2C1 into. Call it into. Because you are drawing out 3 marbles, you are writing your numerator. Denominator is simple. So let me write denominator first so that you understand what we did. We did 10C3 in the denominator. 10C3 is denominator. You did 2C1 because you wanted 1 white and you wanted 1 black out of how many? 3. Therefore 3C1. How many red you wanted? 1. Out of how many? 5. 5C1. That's a part for A. This is how you have written. Okay, I will not simplify. I will put it to perspective so that you will understand what we are doing. That's A. Let's come to B. If 3 balls are drawn, one after the other, now this time, look at the way, 3 balls are drawn, not at a time. In the first question, 3 balls are drawn out at random. That's simultaneously, just 3 are drawn out. Here what you are doing, 3 balls are drawn, one after the other. One after the other, find the probability that they are drawn in the order red, black and white. They are in the order drawn in the for red, black and white. Order is important. Good. So therefore, what is the part B here, or how is B here? First, I want to draw out a red, and then I want to draw out a black, and then I want to draw out a white. 3 balls are drawn one after the other. Fine. What is when we are drawing a red? How many are in your favor, friends? 2 reds are it. Now 5 reds are in your favor. 5 reds are in your favor. You can write 5c1 also. 5c1 divided by 10c1. What do you mean by 10c1? There were 10 marbles were there. Alright, there were 10 marbles. So any of them, alright, now any of them, I think like not convert everything to balls here. Otherwise there are balls and marbles, right? So I was thinking that I am pronouncing two different things. Okay, call it as balls. Yeah, so because all questions are talking about balls after that, because questions are referring to balls, just go to the question stem or go to the information and change it to balls. Yeah, okay, so therefore all it now, so we are talking about three, all it now three balls are drawn one after the other. Find the probability that the first of them is red, first in that order, because the word is order. Red followed by black followed by white. So red, what you will write, 5c1 by 10c1. Can I directly write it as 5 by 10? You can write it as 5 by 10 or 5c1 by 10c1 or 5 by 10. Very good. Okay, now the next one, now it is saying that okay, the next one is what? The black. So how many blacks are there? Still all three blacks are there, all three blacks are there. Therefore 3c1 you will write, nothing but 3 divided by 9c1. Why 9c1? Because you already pulled out one ball, right? So therefore only 9 more balls are left. Therefore 9. What is 9c1? 9. You can write 9c1, no problem, but ultimately you will write 9. Therefore I'm just taking that liberty to write that 9. That's it. Okay, 3 by 9. Good. So next one, all right, now white. How many whites are there? All three whites are intact. You didn't use any of them. Therefore 2c1. Good. But how many are there in total in the box now? Only 8 are there. Therefore you write it as 8. 5 by 10, 3 by 9 and 2 by 8. You will simplify. That becomes the answer for B. Why? Because the word order is important. All right, now here the word order is important. In that order, therefore you wrote it here. Now go to C. Now go to C. Now how C is different from B? If three balls are drawn one after the other, you are drawing out three balls. Find the probability that each one is of a different color. Fine, no order here. Each one of them is of a different color. It's an extension of B. C is an extension of B in the sense I still want each color, but it can be it can be red, blue, white. No, or red first, or what I meant here, red first, blue next, and then white. You may say that no, yeah, red first and then white and blue. Fine, that's a different order. Or you may say that okay, no, first is white and then it's a blue. First is white and then blue followed by red. You may say that no, first is white but then it is red followed by blue. Likewise, you can write the remaining cases as well. For this case, you already wrote here. What is this case here? This is this case. This case. Yeah, what about the second case? Precisely same number, the order gets changed. Let me write it here. What is that you wrote for red here? 5 by 10, because it's already here. You wrote that 5 by 10. What about blue, friends? What about blue there? So blue already you wrote it as 3 by 9. What about white there? 2 by 8. Good. Okay, now look at all it. Now first one is red. Let's say that the first one is red. First is red is 5 by 10. Next one is white. Already you would be writing it as 2 by 9, because white, there are two whites here, therefore you would be writing 2 by 9. Next one is blue. Already therefore white, blue or next one is black, sorry. Already therefore 3 black out of how many? Out of 8. So denominator, did it change? No. 10 into 9 into 8. Here also 10 into 9 into 8. Yeah, what about the numerator? Same numbers. There is a 5, there is a 3, there is a 2. Here also there is a 5, there is a 2, there is a 3. So therefore what you do? Yeah, what is the difference between this first question and the second question? In the second question, you still write 5 by 10, 3 by 9 and 2 by 8. You would have written it, but you would have multiplied this by 3 factorial. That's the difference. You would have multiplied by 3 factorial. Why? Because these three words R, B, W, all that can come in 3 factorial ways. First can be red, or the first can be white, or the first can be black. All right, now you have red, white, black. All right, you have red, white, black. Any of the three can come first, followed by the remaining 2 and followed by the remaining 1. That's the difference between B and C. My point here is whenever application gets little trickier, be mindful about this. Is there an order important there? Is there no order important there? Am I picking all three at once, or am I picking one after the other? You need to be little mindful about that. All right, that's a whole point. Okay, let's go to D now. Let's go to part D. How D is different? Part D. All right, take a look at the part D. All right, let's take a look at the part D. If three balls are drawn one after the other with replacement, another new word is coming. You are replacing every time. All right, find the probability that each one is of a different color. Each one is of a different color. Three balls are drawn. Right now, with the replacement. Good. Again, the order is important. Again, the order is not important. Why? Red, blue, white may come. Or you may say that no, yeah, first is red, but then it is white followed by black. Likewise, you can write this. That is nothing but 3 factorial, because there are 3 different colors. With replacement means what? 5 by 10. Red is 5 by 10. Yeah, what about black? 3 by 10. Yeah, what about white? 2 by 10. 2 by 10. Why? Because every time you replace, there are again 10 balls every time. So therefore, first you pick the red one, then you pick the black 3 by 10, then you pick the white, which is 2 by 10, and multiply this by what? 3 factorial. Why 3 factorial? Because why it should be red, black, white first? It can be white also first, it can be black also first. Therefore, multiply by 3 factorial. Right now, this is where your counting comes in the picture. This is where your counting comes in the picture. Good. I hope all of you understood the difference between these 4 cases. Very elementary, guys. All now these 4 cases you should understand. So as you go into the depth of some of the questions, you understand that this is what the fundamental that you are going to appreciate. The question may get trickier, the question may get lengthier, but the fundamentals remains this. Once you are clear about this, it's only a matter of writing the right numbers and calculating the right numbers. All right, fine. Let's go next. Let's go to the next one. Let's go to the next one. Yeah, the importance of the word at least one, which we already know from the previous lecture. That's permutation 2. I introduced this. Permutation 1 or 2, permutations class 2. I introduced this. Here we go. Probability of A solving a problem is 2 by 3, and the probability of B solving a problem is 1 by 2. What is the probability that the problem is solved? Probability that problem is solved. 3 cases will come here. Probability that A solved the problem, but B did not solve the problem. That is when the problem will be solved. Assume that we both are doing a math problem. I am doing from this end, you are doing from the other end. So when will the problem be solved? Either you solve it or I solve it or both solve it. Alright, we said that okay, we'll try. Alright, now some EOM question has come there, and our online mock question has come there. So then you are saying that okay, let's solve it, let's try. I said so, you are trying there and I am trying here. When will the problem be solved? Either you should solve it or I should solve it or both should solve it. These are the 3 cases. A solved it, B did not solve it. Alright, now A did not solve it, but B solved it. Fine, that's also fine. B solved it. Or A, both of them solved it. Fair enough. Alright, now A also solved and B also solved. So any of these cases we call it as problem is solved. Look, what is the one case missing here? What is that one case missing here? Both did not solve. A did not solve and B did not solve. That is when the problem remains as it is. Then we have to approach somebody else. Alright, problem did not solve. This is nothing but the total probability. Put together it is become 1. Alright, that's 1 because there are only 4 cases. Alright, no, both of them could not solve the problem, or exactly one of them could solve the problem, or both could solve the problem. These are the 4 cases here, which is equal to 1, which is equal to 1. What I don't want this. Therefore, this is the required probability. This is the required probability. I can take this on this particular side. Alright, that is where that at least one concept comes. In the sense, probability, alright, now probability required, which means the problem is solved, is nothing but 1 minus, this is 1 here, this is the 1 minus probability of none solve the problem. None. Alright, none of them solve the problem. At least one. Alright, in the sense, what I'm trying to say is probability of at least one. Probability of at least one. Technically, that's how you remember from your high school. Your teacher would have clearly gave you, already they would have clearly already now drilled you down your memory. Right? Probability of at least one is nothing but 1 minus probability of none. Alright, now that's clear cut. Alright, now that could have been registered in your mind. So that's what we precisely do here. What is probability of at least one? 1 minus. Alright, 1 minus probability of none of them solved, which means A did not solve, also B did not solve. What is the probability of A solving? 2 by 3. Therefore, what is A not solving? 1 by 3. Probability of B solving? 1 by 2. Therefore, B not solving? 1 by 2. Therefore, use it 1 by 3 into 1 by 2. That is nothing but 1 by 6. Therefore, the required answer is 5 by 6. Okay, simple one. Simple one. I illustrated the complete features here. Complete features here. So with that you will understand. So basically this is the box. Probability of at least one. At least one is a very popular phrase being used in the exams. At least one is nothing but 1 minus none. That's the best way to understand it. That's the best way to understand it. Okay, let's go to the next one. Biased. See, wherever it is not required, I'm not spending much time. I'm just spending a minute there, minute two, or a couple of minutes there, right? I'm not even trying to do the second example because I'm confident that you will be able to do from there. You will be able to do from there. I will give all possible inputs on this particular chapter. That's what I'm trying to attempt and do. Okay, here we go. Let's try this now. When a dice is, think about it for a minute. It's a beautiful question. It's really a beautiful concept. Not about question, it's a concept. But you know it. Already you kind of know it. Try and connect with this. I'll leave 1 minute for you, for you to think. Please think, guys. Already now don't keep hearing. Don't be a passive listener. Be active. That's a problem with online. Right? So if you are sitting in front of me in the class, I will make you think because I can understand whether you are thinking or not. Right? I can understand because your pen will be moving, your hand would be writing. It's easier. Sitting there, you may wait for me to do it. Don't wait for me. Right? So you start doing. When I ask you to think, you better think. It's a mental gym. We got to think. All right, let's do this. Think about it. A minute, I leave it to you. Beautiful question, isn't it? Yeah. So no matter what, whether it is biased or unbiased, see, generally, whenever nothing is mentioned, it is taken as unbiased. It is taken as unbiased. So here it has become biased. How do you make it biased? You can do that, right? So basically, make those heavy faces, make those solid wherever even number is there, make the odd number face heavy. Use a different material. There is a dice, right? On a dice, what you do is, okay, if there is already, if there is this particular face, already the face on the top is 2 and the face at the bottom is 1, bottom, this is bottom, face at the bottom is 1, what you do is you use a heavy material for the base. That's it. Use a little different thickness, different gauge, heavy material. Then it will try to rest on it. When you roll it, when it comes solid, it will try to rest on it. That's what you mean by making it biased. You don't use the same kind of material across the faces. You use kind of a different kind of material across different faces. That's how you make it biased. Solid. Thereby, there is a favor of getting a particular outcome higher. Okay. Anyway, that's a science. Solid. Don't worry about it. That's I'm talking about. How do you build the material, etc., etc. Don't bother. Let's go to the now let's go to probability back here. When a dice is rolled, the probability of getting an even number is thrice the probability of getting an odd number. Okay, so what are the outcomes here, guys? Let me write the outcomes here quickly. What are the outcomes here? Outcome is probability of getting 1. All right, probability of getting 2. These are the outcomes. When you roll a dice, what should happen? 3 or 4 or 5 or 6. 6. Okay, what did you write earlier? We said that probability of getting 1 is 1 by 6. All right, now say, let me write it like this. For your ease, let me write it like this. Probability of getting 1 is A. Probability of getting 2 is A. What is this? This side I'm writing. This is unbiased. This is unbiased. This is unbiased dice. All right, probability of getting 3 is also A. Getting 4 is also A. Getting 5 is also A. Getting 6 is also A. Okay. What is the total probability? Right, total here. What is the total probability? Total probability is 1. What is that you are trying to say? 1, 2, 3, 4, 5, 6. 6A is equal to 1. 6A is equal to 1. Very good. 6A is equal to 1. Therefore, A is equal to 1 by 6. Therefore, probability of getting 1 as the outcome is 1 by 6. Probability of getting 2 as the outcome is 1 by 6 and so on. So, everything is 1 by 6 there, right? Yeah. So, that's pretty straightforward, which we are all aware of. Which we are all aware of. Hey, why did I write A and show that? Just to illustrate that, how do you get it then? How do you get? Okay, now take a look about this. Probability of getting 1. Let me call probability of getting 1 is equal to X. That just like the way I used A. Now this time it is nothing but biased. I'm talking about the biased dice. This is biased. On the biased dice, probability of getting 1 is X. What is probability of getting 2? 3X. Who said? Author only said. Probability of getting an even number is thrice. Thrice the probability of getting an odd number. Therefore, probability of getting 2 is how much? 3x. What about probability of getting 3 or x here? What is probability of getting 4? 3x. Likewise, all right, now this is x and this is going to be 3x. Add them, friends. How many x's is this? Hey, what is the total probability? Total probability is 1. Correct, we know. That is equal to, now look at the x's here. It's 4, all right, now, so 5. Then, all right, now, likewise, you are saying that 12x. 12x is equal to 1. Therefore, what is that you are trying to say? 12x is equal to 1. Therefore, x is equal to 1 by 12. So, you are saying that, therefore, probability of getting an odd number is 1 by 12 and probability of getting an even number is 3 by 12. Okay, 3 times of 1 by 12, 3 by 12. You can write it as 1 by 4 also. It does not matter. This is what matters. All right, this is how you get to write the numbers. Okay, now what is the question here? Let's go to the question. Now we are ready with the probability. Probability of 1, 1 by 12. Probability of 2, 3 by 12. Okay, what is probability of 3? 1 by 12. 1 by 12. Any odd number is x. X is there here, right? 1 by 12. What is probability of 4? 3 by 12. And so on, and so on. And you understood what I'm trying to write. Okay, so now let's go here. What is the, when the dice is rolled, how many times? 3 times. There is the first time you rolled it, second time you rolled it, and third time you rolled it. 3 times you rolled it. So thrice the probability of getting a sum of outcomes as 6. Sum should be how much? 6. So how many ways I can get this 6? It's possible that 1 here, or now 1 here, or 1 here, 1 here, and you are maybe getting it as 4 here. That's one way. Very good. 1, 1, 4, that is one case. Second case, you may say that, okay, I'm just writing a pattern here. I'll come to the details later. 1 here, 2 here, and 3 here. Correct. That's one other case. 1, 2, 3 can be other case. The other case could be what? 2 here. Therefore, 2 here and 2 here. Right, that's a third case. All right, now 2 here, 2 here, and 2 here. That's a third case. That's it, only 3 cases. But each case can be permuted. You said that first time when you rolled it, you got 1 and then 1 and 4. I will say that, hey, first time you got 4, the other times you got 1. Correct? Who said no? No, no, no. Second time you got 4 and the other 2 times you got 1. Correct? I'll permute it. Therefore, what I will permute it into 3 times. Let me write the numbers now. So, what is the probability of getting 1, my friends? 1 by 12 into, because the first one, second one, and third one you rolled it 2 times. Sum is 6. Does not mean that you are going to add 1 by 12 plus. You are not going to add. You are now writing a probability. You got the outcomes as 1 comma 1 comma 4. What is the probability of getting 1 in the first or in the first roll? 1 by 12. What's the probability of getting another 1? Another 1 by 12. What's the probability of getting 4 even number? That is 3 by 12. Well, that is 3 by 12. So therefore you are saying that this into this into this is what you are doing. But this can be permuted in how many ways? 3 ways. Why 3 ways? Why 4 should be in the last trial? 4 can be in the second roll also. 4 can be in the first roll also. Therefore what? Into 3. Or all right, therefore plus another case. Another case. What is another case? 1 into 2. 1, 2 and 3. Probability of getting 1, 1 by 12. Probability of getting 2. All right, probability of getting 2. All right, that's nothing but 3 by 12. Probability of getting 3, that is 1 by 12, odd number, that is 1 by 12, into how much? 3 plus third case, case 1, case 2. Now I am writing the third case. Hey, what is this? 1, well, this is nothing but 3 by 12 into 3 by 12 into 3 by 12. How many times? 3 times. 3 times. That becomes your answer. In the sense, when you are writing the answer to this, when you are writing the answer to this, you write it like 12, 12, 12. 12 cube is common in the denominator. 12 cube is common. Yeah, what all 12 cube is common? 3 is also common because this 3 is also common. This 3 is also common. First case, write it. The first case, therefore, first case is 3 into 1 into 1, which is 3 plus. All right, second case, 1 into 3 into 1, another 3. Okay, third case, 3 into 3 into 3. All right, that's another case. All right, now which is nothing but 27. 27. You calculate this, whatever becomes, that is your answer there. I hope everybody got this particular answer here. All right, it's a beautiful question. Beautiful question. Okay, the point is not this. Point is not this. I'm not interested in this because this will be very, very clear after permutation combination. The point is I'm interested in the biased nature. How do you equate 1 to 12? That's what I'm interested in. Right now, how do you learn to write this x, 3x, x like this? How do you learn to write, and you will find the probability from there. All right, getting onto this particular platform. These are important to me. How do you understand this platform and how do you understand this? That's important. That biased part, how do you put it to perspective? That's important because after that, it's a simple calculation. Simple calculation. Good. I hope everybody is getting this and you are enjoying this. Let me go further. Let me go further. Conditional probability. Let's introduce to this. Let's introduce to this because Bayes' theorem depends on conditional probability. We'll try and see towards the end. We'll try and see towards the end. Okay, we are into the last 30 minutes of the lecture, friends. Push yourself. Push yourself. Last 30 minutes, but we are going to learn something exciting as we go along. Very important, very foundation, very fundamental ones. One should be very, very clear about this. Right? These are the things. So of course, the questions can be made a lot more lengthier. If you look at this, I'm keeping the questions simpler. Why? So that we'll get understanding of the concept. I don't want to complicate the question itself. Then it will not make sense. Then we'll be carried away by the question rather than carrying away by the, or being carried away by the concept. Let's be carried away by the concept. Let's soak into that. That's more important first. After that, the questions, all right, they twist all that. But the concept is clear. It's a matter of time to understand and resolve the issue. So here we go. Let's understand what is conditional probability. Conditional probability is nothing but some partial outcome is known. Partial outcome is known. You know some partial outcome. Therefore, the final probability changes. Because you know certain partial outcome, final probability changes. Now look at this. If I just ask you this question, find the probability that, all right, find the probability that the given number is a multiple of 3. Given number is a multiple of 3. Your answer is different out of 100 natural numbers. Out of 100 natural numbers. All right, the given number is a multiple of 3. That is different. But now look at this. What is that he is trying to say? He is saying that given that it's a multiple of 5, which means already some probability is defined. See, look, first sample size was this. All right, first sample space was 1, 2, 3, 4 up to 100. So that is the first sample space. All right, that's what he said. A number is selected at random from the first 100 natural numbers. 100 natural numbers are there. Now, a selected one, when you selected what it became, given that it became a multiple of 5, you are not telling me what is that number. Assume that there are 100 cards in front of you. You picked out a number and you are challenging me from there. In the sense, you are informing me from there. Hey, I got a number. All right, I picked one number out of 100 natural numbers. It is a multiple of 5. You said that. Multiple of 5 means what? What is running in my mind? Yes, one. Another sample says, what is running in my mind? A probability probably you might have got a 5 there, you might have got a 10 there, you might have got a 15 there, you might have got a 20 there, like this, right? 95 and 100. I know that, hey, this is what has happened, which means here there are 100 observations. From 100 observation, it came down to 20 observation. When you simply picked one card out of 100 cards, I know that it was 1 out of 100. But it's from 1 out of 100, now I know that, hey, it is out of this 20, 1 out of 20. That is the conditional probability, friends. Now it is not 1 out of 100 because you gave me little information saying that it is a multiple of 5. It has become 1 out of 20. Instead of 1 out of 100, my imagination has now come down to 1 out of 20. Now in this, now this out of this 1 out of 20, now what is that he's saying? Find the probability that it's a multiple of 3. It's also a multiple of 3. Now you already have the multiples of 5. What are these numbers? These are multiples of 5. Now I want a multiple of 3 as well. A number should be a multiple of 3 and multiple of 5. Think about it. There is a number n which should be a multiple of 3 and multiple of 5. Why? Multiple of 5 is already given. It's a multiple of 5. This is a sample size. It should be multiple of 3 as well, which means what? Multiple of 3 and multiple of 5 means multiple of LCM of 3 and 5. Numbers chapter, LCM of 3 and 5. Therefore it has become a multiple of 15. How many multiples of 15s are there? So therefore you are saying that, okay, now what is finally in my favor? Another S2. What is finally in my favor? 15. 15 2 times 30, 45, or let's 60. Now 60, 75, 190. So you are technically trying to say that 6 numbers are in my favor. 6 out of how many numbers? 20 numbers. You're shortlisted. 6, 15 is in my favor. 30 is in my favor. Like this, you went down to write it. How many are in your favor now? 6. Therefore, what is the required answer? 6 numbers out of 20 numbers are in my favor. 6 by 20 is my answer, which is nothing but 3 divided by 10. 30% of my numbers are in my favor. Okay, all of you understood. Point here is what? What is conditional probability? Partial outcome is given. Because the partial outcome is given, your probability is going to change. Okay, question won't be this simple. A partial outcome is given is what I'm trying to tell you here. A partial outcome is given. Let's go to some questions built on this, then our understanding will get a lot better here. Hey, what do you mean by this partial outcome is given? Let's see. Let's take a look at this. One more question. Let's take one more question. You think about this, my friends, all of you. Think about this. I'll leave you a minute. Think about this. If you have understood what I meant by partial information, just think about it for a minute. Think about it for a minute. Okay, what is this question basically, right? What is this particular question? What is it trying to say? Assume in your room, all right, wherever you are sitting, all right, wherever you are sitting, in whatever the setting that you are sitting. So there is a box one, all right, in that box one, all right, there is a box one. In this box one, we have 5 white and 6 black. This is the box one. Okay, in the same setting, you have a box two. All right, you have a box two here. Now, what are the ingredients of box two? You have 2 white, you have 2 white and 3 black. You have 3 black. In the sense you have 11. Already you have in this pull there are 11 marbles here. There are 11, and here it is going to be 5 marbles. You have 5 marbles here. Good. Now what is the question? You picked one from here. You pulled out 1 marble from this box, and you pulled out 1 marble from this box, and you said that look, at least one is white. That's what you told me. You picked it. All this action is done over the setting that you are sitting. All right, now that room you have 2 boxes. In one box you have 5 white marbles and 6 black marbles. In the second box you have 2 white marbles and 3 black marbles. You put your hand into each of those boxes, one into the left hand, one left hand into one box, right hand into the other box, and you pulled out 2 marbles. Already you pulled out 2 marbles, and you are saying that at least one is white. Already you are saying at least one is white. You know what are both the colors, but you are saying that at least one is white. Now you are asking me that what is the probability, man? Therefore the both of them are white. Both of them are white. So that's what you are questioning me. Fine. So what can happen here? Alright, what can happen is something like this. Now listen to me carefully here. Both marbles are white. Now this is the conditional probability, because you already told me that one is white. You already told me one is white. These are the 3 things that can happen. Alright, the box one you got white. Box one is white. All right, white, all right, now, so white, all right, now let's see that, let's put it like this. All right, now box 1, all right, box 1 and box 2. You might have got white from here, all right, you might have got white from here and black from here. Or you might have got black from here or white from here. Or you might have got both whites. Or you might have got both blacks. This is ruled out because you have said that at least one white is there. Therefore, I don't have to think both are blacks. So this might have happened. From the box 1, you might have got a white, and the box 2, you might have got a black. Or you might have got a white from the box 1 and black from the box 1. These are the cases, case 1 or case 2 or case 3. This is what three things that would have happened there. So now you are saying that, hey, what are the chances that this has happened? What are the chances that this has happened? Simple. So what do you write here? You say that probability of getting all white from the first box and white from the second box. Probability of getting white from the box 1, all right, white from the box 1. Let me write that here directly. What is the wallet? No, because that's what you are into. Okay, let me write it once. Probability of getting white from the box 1, box B1W, which means what? Box 1 is white, and probability of getting box 2 is also white. All right, box 2 is also white, B2W. What does it mean? All right, that is in your favor. Hey, what about in the denominator? Denominator is simple, friends. This was your case 4. This was your case 4. Total probability is 1. Therefore, what? Okay, let me write all three cases first because it's important to understand sometimes. So in the denominator, you would be writing this. So you would say that, okay, probability of box 1 is white, but probability of box 2 is black. What did I write? Case 1 I wrote plus probability that, probability that box 1, box 1 is black, box 1 is black, and the box 2, probability that box 2 is white. Yeah, what did I write? Second case I write. Similarly, I will add on a third case. What is the third case? Probability that box 1 is white and probability that box 2 is also white. This is what I should be writing. This is the conditional probability. This is the required answer, my friends. I mean, this is the complete thinking. What I'm trying to say is, hey, think properly. How soon you write, what you write is a different issue. But am I able to think all of this? Yes. Now, how do I write this to perspective? You may say that is nothing but numerator is probability that box 1 is white and probability that box 2 is white divided by 1 minus probability that box 1 is black and box 2, probability that box 2 is black. Why? That is 1 minus none of them are white. Probability of none of them are white. 1 minus probability of none of them are white, because this is the case. This is the case. Total minus this, bring it here. Total minus this, you get all these three cases. That's easier to think. That's where I introduced at least one. All right, that's where I already introduced that particular part. So write the values here. Probability, all right, write the values here, friends. Write the values, corresponding values you write. Therefore, that's equal to first one I'm writing here. First one I'm writing probability that the box 1 is white. What do you mean by box 1 is white? 5 divided by 11. Okay, 5 by 11 into second box is already, second box is also white. How many whites are there here? 2. 2 divided by what? 5. 2 divided by 5, whole thing divided by 1 minus probability that the first one is black. All right, now what is that? First one is black, first box is black. 6 by 11. So 6 by 11 into, all right, 6 by 11 into 3. All right, now 3 of them are black in the second box. Out of how many? 5. That is 3 by 5. All right, 3 by 5. We can simplify this, which becomes our answer. All right, which becomes our answer. That's nothing but 10 divided by 55. Whole thing divided by 55 minus 18 divided by 55. What did I do? 1 minus. All right, 1 minus 6 into 3. That's 18. So therefore, you would say that, all right, you will say that the required answer is 10 divided by 37. All right, your answer would become 10 divided by 37 because 55 get cancelled. 10 by 37 is the required answer to this. Pretty simple one. It doesn't take so much time to write because I was illustrating that. What do you mean by conditional probability? How do you write them? So once you understand conditional probability, again, conditional probability used in various different questions, in various different forms. Let's go further. I hope all of you got some understanding about conditional probability. Let's do another one, theorem of repeated trials. Then we'll bring conditional probability into this. Conditional probability as an element is important, no doubt about it. But let's understand what is theorem of repeated trials. Let me explain this. Or binomial distribution of probability. You might have learned in the high school, college specifically. You have learned this theorem in the college. This is called binomial distribution of probability or theorem of repeated trials. Theorem of repeated trials. Okay, let's take a look here, guys. Let's take a look here. Let what is this? To read this question along with the question, I'll explain. Read this question. Harry takes 5 shots at a dartboard. There is a dartboard. There is a bullseye. Now he is trying to take the shot at this bullseye. Okay, so probability of Harry hitting the bullseye in any attempt is 2 by 3. So therefore, what is the Harry missing the bullseye? Missing the bullseye is 1 by 3. If the hitting is solid, now this is hit, therefore this is miss. If the hit is 2 by 3, then the missing the bullseye is how much? 1 by 3. Okay, question. What is the probability that he hits the bullseye in the first, second and fourth? Understand this very clearly. How many times he is hitting? 5 shots. All right, therefore he is saying that first shot, second shot, third shot, fourth shot and fifth shot. Fine, that is my trials. That is my trials. What should happen here? First time, all right, the probability that he hits the bullseye in the first. What is the probability of hitting, friends? He hits here. All right, now second hits, miss. This is going to, all right, fourth one he is going to hit and he is going to miss. That's the first question. A. All right, now that's what he's saying. All right, now he hits the first shot, second and the fourth. Okay, what is the probability of hitting? Therefore you say 1, 2 by 3. He hits here, therefore 2 by 3, because first, second, third, fourth and fifth, therefore into, because you got to hit all, you got to take all 5 shots, whether you hit or not, you got to all it. No, you brought 5 shots, therefore you are trying to hit 5, you are going to aim 5 times here. 2 by 3. What is the probability of missing, friends? 1 by 3. 1 by 3, right under miss 1 by 3. Hit is how much? 2 by 3. Miss is how much? 1 by 3. So I wrote it here. Hit and miss, we are clear here. Hit and miss. Probability of hitting is this. Therefore, you wrote the answer. Fair enough. What is the answer here? 2 by 3 raised to power 3. 2 by 3 raised to power 3 and 1 by 3 raised to power 2. What is 2 by 3 raised to power 3? 2 by 3, 2 by 3, 2 by 3. Therefore, 2 by 3 raised to power 3. What is 1 by 3 raised to power 2? 1 by 3, 1 by 3, 1 by 3 raised to power 2. Fine, you wrote this part. Fair enough. That's for the first question. Look at the second question. B. What is the probability that he hits the bullseye in 3 of the attempts? Which is a global question. Extension of this. First one is a specific case. First, second. Now he says that any 3 attempts, probability that he hits the bullseye 3 of the attempts, in 3 of the attempts. Which 3? Up to you. Which 3 is up to you? You may say that, okay, can I do the first hit and then this is a miss and a miss? That's fine. Or you may say that, no, yeah, alternate hits, alternate shots are hit and then they're miss. Fine. No, last 3 are hits because he was warming up. This guy was warming up. Last 3 are hits and the first 2 are miss. Fine. So for every time, even for this particular case, you are going to write this as the answer. This will be the answer, because you would have written that 2 by 3 in different places. Here you would have written 2 by 3. This is 2 by 3. This is 2 by 3. This is 2 by 3. And these 2 are 1 by 3. So therefore 2 by 3 whole cube, that's what you have. And 1 by 3 whole square, that's what you will get. So next time what you will say, hey, here I will write 2 by 3, 2 by 3, 2 by 3. Fine, 2 by 3 whole cube. So here you are writing 1 by 3 and 1 by 3. Therefore 1 by 3 whole square. The order is changing. Therefore what you will do? Same thing. Instead, therefore now you will say that, hey, this is the first time I'll be writing this box. First time, this is second time, this is third time, this is fourth time. Like this, how many more times? That's a question. Number of more times is nothing but 5C3. Man, where is this 5C3 coming from? Because there are 5 shots. Decide which 3 shots will hit. Decide which 3 shots will hit. That is 5C3. That is 10 times. All right, 5C3. All 5C3 times, what is the number that you'll be writing? 2 by 3 raised to power 3 into 1 by 3 raised to power 2. All 5C3 times you'll be writing this. What is 5C3? 10. Therefore, 10 times of 2 by 3 whole square and 1 by 3 whole 2 by 3 whole cube and 1 by 3 whole square. All 10 times. See, I showed you 4 cases here. I showed you 4 cases out of 10. So therefore, now what is that binomial distribution of probability, or theorem of repeated trials talks about? Probability of R successes. Probability of R success in n trials. In n trials. N trials. Probability of R success in n trials is nothing but NCR, which means which are those R successes, where are those R successes? That's what you are trying to say. NPR, probability of success raised to power R, probability of failure raised to power n minus R. Probability of failure raised to power n minus R. Okay, look at the second question here. B, once again look at that B here. Yeah, what is the value of n, friends? What is the value of n? N is equal to 5. Yeah, what is the value of R here? The value of R here is 3, because 3 times I want to hit the bullseye out of 5 times. Okay, what is the P here? What is the probability of success? 2 by 3. Yeah, what is Q here? That is the probability of failure. All right, that is nothing but 1 by 3. Now these were the ingredients. Therefore, probability of hitting 3 times, 3 hits. Probability of 3 hits is nothing but 5C3. Decide which are the 3 hits. Is it the first, second, third, or is it going to be 1, 3, 5, or is it going to be last 3, that is third, fourth, fifth? Decide which 3 should hit. That is 5C3. And then probability of the success. All right, 3 times there is a success. 2 by 3 raised to power 3, because I want 3 success. If you want 3 success, how many times you should fail? All right, 2 times there should be a failure. What is the probability of failure? 1 by 3. How many times? 2 times. All right, how many times? 2 times. That is what precisely you wrote here. All right, that is what you precisely wrote here. I want you to remember this. This is important. All right, theorem of repeated trials. This is important. Or binomial distribution of probability. Which way you remember doesn't matter, but you should remember. What is important is you should remember this. Okay, so if you got this particular point, what I'm trying to say here, let's try and work on the C here. Let's try and work on the C part here. Let's try and work on the C. Let's try and work on the part C of this question. Let's try and work on part C. Okay, what is the probability that he hits the bullseye for the third time in the fifth trial? All right, now so there are these are the shots here: first, second time, third time, fourth shot, and the fifth shot. What is he saying here? Third time in the fifth shot, third hit should come here. That's a point here. Third hit should come third time in the fifth attempt. If the third hit should come in the fifth attempt, which means in the 4 shots there should be 2 hits or 2 hits. It cannot happen that AR already he has hit here, he has hit here, and he has hit here, and he missed here. And then where is the question of third time in the fifth attempt? No, if it is a third time, it is the third hit. All right, now hit, but this is the third hit. If this is the third hit, it is clear that he might have hit exactly 2 times in the first 4 trials. That is when you write about the third time he hits in the fifth trial. Third time in the fifth trial implies 2 hits in the first 4 trials. Okay, now write it, therefore write it. So therefore first 4 you make it 1 pack, this you make it 1 pack, you make this a separate pack, therefore deal this separately. So you will say that 4C2 any 2 can hit, first and second can hit. Hey, no, your last 2 have it, that's also fine, last 2 have it. You may say that no, first and last have it, first hit and the last one is a hit. All of that is covered in this 4C2. All of that is covered. Whatever the configuration you are thinking is covered in the 4C2. Okay, what's the probability of hitting 2 by 3? How many times? 2 times. Okay, therefore how many times he should miss? 2 times. Therefore 2 by, that's therefore 1 by 3. All right, thereby 1 by 3, that's a probability of a miss. How many times you should miss? 2 times. Okay, now that is taken care of. This first 4 shots, first 4 shots are done. Into what is the third shot? All right, now third shot. All right, probability of this fellow hitting in the, all right, now the third hit. What is the probability of hit? It's a hit only. Don't write 1 means certainty. We are still talking probability. All right, hitting for the third time. All right, third time hit. What is the probability of hit? All right, probability of hit is 2 by 3 into 2 by 3. How does your final answer look like? 4C2 is nothing but 6 times of 2 by 3 raised to power, there is a 2 here and there is one more 1 here. Therefore 2 by 3 raised to power 3 and 1 by 2 raised to power 2. This looks like a final answer. All right, that looks like a final answer. Hey, what is the difference between B and C then? Most of it is same. All right, what is same? 2 by 3 raised to power 3 is same as 2 by 3 raised to power 3. Here 1 by 3 raised to 1 by 3 raised to power 2 is same as 1 by 3 raised to power 2. That's also same. All right, that is also same. No change. What changes is this? Here you wrote 10 and here you wrote 6. That's a difference. All right, that makes the difference in these two probabilities. Great, guys. Okay, that's about this question. If I've understood this question, I want you to try this question. If I've understood the binomial distribution of probability or theorem of repeated trials, I want you to take a look at this question and resolve it. Take a moment quickly. We are into the last 15 minutes of lecture, guys. Another 15 minutes or 15 minutes, we are done. So this 15 minutes, push yourself. Push yourself. I will teach you few more concepts. Push yourself. Good, I'm sure all of you would have written here, all right? Because where is the conditional probability coming? So it said that okay, at least 3 times it's already done, all right? In the sense the number two, all right, number two as the outcome. You rolled a dice, 1, 2, 3, 4, 5, 6. All right, now 5, 6, they are the outcomes. How many times you rolled it? 5 times you rolled it. Number two has come how many times? Already 3 times it has come. Already 3 times it has come. His question is what? What is the probability that it has come? Exactly 4 times. Therefore, what is the question that you are writing? Probability of getting exactly, or probability of getting the number 2 exactly 4 times. Exactly 4 times. Probability of getting what? Number 2. I'm not writing the full sentence. Bear with me. Yeah, probability of getting the number 2. Number 2 is the outcome. I'm interested in number 2. Out of all the outcomes, 1, 2, 3, 4, 5, 6, I'm interested in this. How many times? Probability of getting exactly 4 times. 4 success. Let me write it as probability of getting 4 success. What is success? Getting a number 2. That's success. Probability of getting 4 success divided by, where is that condition coming? Because 3 times is already done. Probability of 3 success. Exactly 3 success, or probability of 4 success. 4 success, or because it said that at least 3 times it has already come there. 4 success, or probability of 5 success. 5 times it has come. Why 5 times? That's it. All right, because it is rolled 5 times. Now don't write probability of 6 success. You rolled only 3 times. Or 5 times. Therefore 3, 5, all 5 times it could have come. So therefore this is what you are going to write. Probability of 4 success. How do you write, my friends? Probability of 4 success. What is the probability of getting a number 2? What is the probability of getting number 2 as the outcome when you roll a dice? That's 1 by 6. That's 1 by 6. Very good. Therefore, what is the probability of not getting number 2? What's the probability of not getting a number 2? 2 dash. I am not getting number 2. That is 5 by 6. Probability of not getting number 2 is 5 by 6. Perfect. All right. Probability of not getting number 2 is 5 by 6. Good. Write it here. Therefore, this is a success and that's a failure. So now you are writing that probability of getting 4 success. 4 success means what? 5C4, because 5 times you roll the dice. 5 times you roll the dice. First time you rolled, second followed you want to do 4 times. Assume that these are the 4 times, and then you got a 6 here. You got another outcome which is 6, something other than 2, right? That's what you mean here. 5C4. Therefore, which 5, which 4? That depends. Or you may say that no, here there was a 6 here and then I was getting 2s here. Fine, that's also fine. That's what you mean by 5C4. So how 4 successes? All right, 4 out of 5. So what is the probability of success? 1 by 6. Raised to power what? 4. What's the probability of failure? 5 by 6. Raised to power what? 1. Raised to power what? 1. Good. Okay, now then you are writing these values. You are writing this 3 successes. Therefore, you will say that 5C3. 1 by 6 raised to power 3. 1 by 6 raised to power 3. And 5 by 6 raised to power 2 plus 5C4. This one, next one, 5C4. All right, 5C4. Then 1 by 6 raised to power 4 and 5 by 6 raised to power 1 plus last one here. All right, last one. All right, last one, 5C5. 5C5, that is 1, and then 1 by 6 raised to power 1 by 6 raised to power 5. 1 by 6 raised to power 5. You can write 1 by 5 by 6 raised to power 0, that is 1 only. Right? Technically, this is your answer. This is your answer. So what did we do? We applied binomial distribution. We also applied conditional probability. Where did we apply conditional probability? At least 3 times it has already come. Therefore, what? All right, therefore, what is the chances that it would have come exactly 4 times? What did we do? We understood binomial distribution. We understood conditional probability. We put both of them together. We put both of them together. Good. Let's go a little further. A little further. These are some phrases that they use. All right, these are some phrases that they use. That is odds in favor and odds against. Odds against. What do you mean by odds in favor of an event? Odds in favor of an event is a ratio. Odds in favor of an event is a ratio. For example, if I say that, hey, if I say that, okay, so there is a dice. All right, you rolled a dice. These are the outcomes possible. These are the outcome possible. All right, you define an event A. All right, let's say you defined an event P. Not P, let's call it as you defined an event, event N. All right, there is an event N. What is an event N? Getting a multiple of 3. Let's say getting a multiple of 3. What are the multiples of 3? 3 and 6. 3 and 6. So therefore, what is in odds in favor of N? Odds in favor. If I use the word odds in favor, odds in favor of N. If I use the phrase odds in favor, I should write the favorable outcomes. How many outcomes are in favor? 2 outcomes are in favor. Is 2. How many are not in favor? Remaining 4 are not in favor, because 3 and 6 are in favor. What about the remaining 4? They are not in favor. So therefore I will write this as 1 is to 2. 1 is to 2. That's fine. That's the meaning of odds in favor. For the same one, if I use the phrase odds against N. If I use it as odds against n, odds against n means first write against n. How many are against? 4 are against. 4 of them are against. Good. So therefore next number what you should write, how many are in favor. Therefore odd against means 2 is to 1 you will write. 2 is to 1 you will write. Now from here what is the understanding? So if I give this odds in favor and against, which means odds in favor of n is 1 by 2. If I give these statements, odds in favor of n is 1 is to 2. Therefore what is probability of n? Probability of n is nothing but favorable divided by total. Yeah, what is favorable? 1. What is favorable? Because favor is the word here, therefore favorable is 1. So what is the total? 1 plus 2. What is the total? Favorable as well as unfavorable. Therefore probability of n is nothing but 1 divided by 1 plus 2. Okay, what if I would have given you this statement? I would have given you this particular statement, odds against n is 2 is to 1. Say I would have given this particular statement, odds against n is 2 is to 1. Therefore what is probability of n? Against means the first number is going to be against, that much you know. Therefore use this is favor, the second one is going to be favor, therefore you write 1, that is a favorable one, divided by total, favorable as well as unfavorable. Therefore you get the same answer. Of course it's 1 by 3 and 1 by 3 only, but where to pick that number 1 is important. Alright, here if it is odds in favor, you pick the first one. If it is odds against, then the next number is going to be favorable one. Alright, that's what you got to kind of get hang of, right? Now that's in odds in favor, odds against. Good. Alright, if you have got this question, let's try the first one, A first here. Let's try A. Alright, let's try the part A here. Let's take a look at this question first of all. Odds in favor of ABC solving a problem are 2 is to 3, 1 is to 5 and 3 is to 5. So what is given to me? Odds in favor of ABC is given to me. Good. So therefore probability of A. Let me write probability of A, my friends. What is probability of A? 2 divided by 2 plus 3. Why? Because the word is favor. Therefore the first number stands for favor. 2 divided by 2 plus 3. In other words 2 by 5. That's probability of A. Okay, what is probability of B? What is probability of B? 1 divided by 1 plus 5. Nothing but 1 by 6. What is probability of C? 3 divided by 3 plus 5. Nothing but 3 by 8. Nothing but 3 by 8. Now question is, what are the odds in favor of the problem being solved? Odds in favor of solving a problem is this. What is the probability that the problem is solved? We already know that. What is the answer here? Probability, total probability. Answer, probability of problem being solved. Problem being solved, which means at least one of them should solve. 3 friends, I am solving here, you are solving at your place, and one other person is solving at his place. Let's say, what's the probability of problem being solved? At least one of us should solve. Therefore at least one of us should solve. That is when you say that the problem is solved, which means probability of at least one of them solve the problem is nothing but 1 minus probability of none of the folks have solved the problem. None of them have solved the problem. Therefore what you write the complement side of it. What is probability of A not solving the problem? Already not solving the problem, 3 by 5. 3 by 5 is probability of A not solving the problem. What is the probability of B not solving the problem? 5 by 6. 5 by 6, that's probability of B not solving the problem. Hey, what's the probability of C not solving the problem? 5 by 8. Well, that's going to be 5 by 8. That's probability of C not solving the problem. I use this here. Therefore 1 minus A did not solve the problem, B did not solve the problem, and C did not solve the problem. And C did not solve the problem, right? Yeah, that becomes my answer. Therefore 5 gets cancelled. This is 3 2 times. Therefore you are saying that 5 divided by 16, or let 5 divided by 16, which is nothing but 11 divided by 16. Required answer is 11 divided by 16. That is the probability that the problem is solved. Or let 11 out of 16. Good. Okay, now second one I want you to do, having understood this, all the numbers right in front of you. Well, in the sense we already wrote the probability in favor, etc. All the numbers are right in front of you. How to use that ratio. And now I want to do B part of it. That was important to me, right? That part was important to me. Use it, my friends, in this B part. Use it. Conditional probability. Same information where there is a conditional probability involved. There is a conditional probability involved, right? I guess you could write it. Okay, given that the problem is solved, what is the probability that A alone has solved the problem? What is the probability that A alone, right, A alone has solved the problem, which is something like this. What you are trying to say this, well, now probability of A solved the problem, A solved the problem, B did not solve the problem, B did, all right, A solved the problem, all right, probability that A solved the problem, probability that B did not. Okay, let me write everything in one bracket, you will understand, I'm sure. A solved the problem, B did not solve the problem, and C did not solve the problem. That is what you mean by A alone has solved the problem. So what is given to me? Problem is already solved. Problem is solved. Problem is solved means what? 1 minus. What is the denominator? 1 minus probability of none of them solved. 1 minus probability of none of them solved. That's a numerator. See, more often than not, conditional probability is probability of favorable divided by probability total. Alright, whatever is that, conditional, probability conditional. I cannot say total. Total is nothing but probability conditional. Alright, that is how it looks like. So therefore you have the probability, all the probability of A, B, C. So how do you write this? Therefore you would say that this is nothing but, alright, this is nothing but probability that A solved the problem. Alright, write it guys. A solved the problem is how much? What you will use? 2 by 5. A solved the problem is 2 by 5. B did not solve the problem. You use this 5 by 6. B did not solve the problem. C did not solve the problem. 5 by 8. Whole of this divided by 1 minus none of them solved the problem. 1 minus none of them solved the problem. We already know that this is 11 by 16. How do we know 11 by 16? Previous question. I extended the logic of the previous question. I made a conditional probability on that, right? Yeah, so therefore we have 11 by 16 here. 11 by 16, that becomes my answer. All right, simplify this. Once I simplify this, which technically becomes the answer to this particular question. Good. I hope all of you got this answer there, got this point here. So how I am using this conditional probability inside binomial theorem, inside odds against or odds in favor, wherever you want, you can use this conditional probability. Let's go further. This is Bayes theorem, friends. It's very much conditional probability. No big deal about it. No big deal, no fuss. That's a Bayes theorem. Let's come to this. Even without understanding it's a Bayes theorem, you can solve. Nothing but conditional probability. Take a look at this question. A person is known to speak truth 3 out of 4 times, right? What is the probability of person speaking the truth? Therefore, if I say first statement, probability of speaking the truth is 3 by 4. What is the probability of lying? Probability of lying is 1 by 4. That's it. Either, because whenever you asked a question, either you are telling the truth or you are not telling the truth. Not telling the truth is a lie. All right, that's nothing but 1 by 4. That's the first one. He rolled a dice. Assume that you already know. So you are doing this action from your place. Let's assume you rolled a die. You have a die at your place. Probability that you speak the truth is 3 by 4. Probability that you lie is 1 by 4. Take it. All right, now it's easier to understand. I'm just making a activity here. Right? 3 by 4. Probability of you telling the truth is 3 out of 4 times. Probability of you lying is 1 out of 4 times. Okay. Then he rolls a dice and claims it to be 3, which means you rolled a die and you said that I got 3. Now I am on this side. I'm on the other side of the camera. I'm here on the other side of this. You rolled a dice and you said 3. You might have said the truth or you might have lied also, because already now you have some probability of lying as well. Therefore, already now you might have, based on this question, just an activity, you might not be lying. That's a different issue there. So just a question there. That's a question here. So you rolled a dice and you said that, hey, I got 3. Already you said that you rolled a dice and you said that you got a 3. Point here is what? You might have got a 3 or you might not have got a 3. Therefore, how do you get this here? What is the what would have happened here, friends? This might have happened. Alright, you got a 3. Probability of getting a 3, and therefore you probability of telling the truth. You got a 3. Alright, now so you rolled a dice. What is the probability that it is 3? It is 3. That's a question. Probably you got the 3 there. Therefore, you told the truth. Or probability that you did not get the 3, you got something else, you got 5 as the outcome, some other outcome you got, you did not get the 3, but you are claiming that, hey, I got 3. You are claiming wrong thing. Therefore, probability of lie, you lied it. All right, you did not get a 3, but you claimed it to be 3. Therefore, what did you do? Lie. That's a denominator, and this is what we were doing so far. Now what is numerator here? What is the probability that it is 3? It is 3 means what? This is the favorable case. This is the favorable case. Probability of 3 and you told the truth. That is when it is going to be 3 there. If I combine, if I should put the camera, if you put your camera and show it to me, look, it is 3 here. So this is what it is. Yes, it is 3, and you told the truth. Possible. All right, no, but when you claim 3, it can be this is also possible. It is not 3, and you lied. That's also possible. That becomes already your denominator. Nothing but your conditional probability only, friends. But here, what happens here is two probabilities always get multiplied in a Bayes theorem. In a Bayes theorem, two things get multiplied. Conditional probability only. Two things get multiplied, this and this, probability into another probability, probability into another probability. We are used to this. We are multiplying 3 probabilities also in the previous question. All right, go back to this video later and check it. So therefore Bayes theorem is already no big difference to us. Just that Bayes theorem looks nothing but a part of binomial part of conditional probability. Write down the answer here. Probability of getting a 3 is how much? Probability of getting a 3 when you roll your dice. When you roll a dice, what is the probability of getting a 3? When you roll a dice, the probability of getting a 3 is 1 by 6. Hey, what's the probability of not getting a 3? 3 dash. Probability of not getting a 3 is 5 by 6, because any other outcome is fine. Put on your answer, therefore. Probability of getting a 3, 1 by 6. Probability of telling the truth, 3 by 4. That's your numerator. What about your denominator? Same thing, 1 by 6 into 3 by 4. 3 by 4, that is the first bracket here. This is the first bracket. Plus probability of not getting a 3, 5 by 6, and probability of telling a lie, all right, probability of telling a lie, all right, that's 1 by 4. Yeah, that's 1 by 4. Probability of telling a lie is 1 by 4. So this is what you are calculating. So therefore denominators are same, it gets cancelled. 3 divided by 3 plus 5, your answer is going to be 3 by 8, which would be your answer to this question. It's a kind of, this is an example, classic example of Bayes theorem. Don't bother, it's an IFT question as well. This question what I did is an IFT question. I'm not sure about the numbers 3 out of 4 or whatever. I think it is 3 out of 4. All right, but it's an IFT question what it is. It's Bayes theorem, but it's a conditional probability. If you know conditional probability, you are done with this question. You don't have to bother too much about this. If you know conditional probability, people call it Bayes theorem, etc., but it's pretty similar to the conditional probability there. Okay, all right, let's do one last element. With that we will be done. So because so far what we did is discrete probability. So far whatever we did is called as discrete probability. It is discrete. Discrete means what? Count. I can count the instances. Discrete probability. But of course 90% of the questions are based on discrete probability, no doubt, but there are 10% of the questions which are based on continuous probability. Continuous probability. All right, now they know discrete. Continuous means what? You got to think about lines. All right, because there are a lot of points on lines. There are infinite points on lines. Points on lines, right? Are the points on lines, or points in area, number of points in area, both are infinite. How many points are there on a line? Infinite. How many points are there in an area? Infinite. Therefore it becomes continuous. You can't count the number of points on a line. You cannot count number of points in the area. All right, now therefore all right, that is called as the continuous probability. It's continuous. Points are continuous to form a line. Points are continuous to form an area, right? That's a continuous probability. So far what we did is discrete, because we know that more than 90% is the discrete question, but there are always about those 10% of questions which are continuous. Let's do understand this last part. Two simple questions just to illustrate, because the questions on continuous are going to be literally very simple. Literally very simple. I will give an orientation to this so that when you look at those continuous probability question, it strikes you, you understand that okay, this is what it is, right? Let me give an orientation to that quickly. Last 5 minutes and we are done. 5 to 6 minutes maybe, right? 5 to 6 minutes and we are done. Okay, let's take a look at this question. When a point is selected at random on a circle, what is the probability that it is closer to the center than circumference? All right, than circumference. Okay, so what has happened is, so you have a circle. All right, there is a circle. Let us say that the radius of the circle, radius of this outer circle, radius of the outer circle is 2x. You'll understand why 2x. I'll come to it. Radius of the outer circle, let me take it as 2x. That's a radius. Okay, fine. So let me write concentric, another circle, inner circle. All right, let me write inner circle. Therefore radius of inner circle is x, 1x. Nothing but x. Radius of inner circle is x. So if that point is anywhere inside this, then it will be closer to the center. If a point is anywhere inside the black circle, it is closer to the center, right? If the point is, because this is r here, already now this is nothing but x here, till here it is going to be x. All right, then all right, from here it is going to be 2x. All right, till this entire line is 2x. Therefore x, all right, now basically you divided that as x and x. All right, that is x here. Hey, what about this here? All right, if I continue this particular line here till here, this is another x. All right, x and x. Therefore, if the point is in the black circle, as long as the point is within the black circle, it is closer to the center than circumference. That's what he's saying. Hey, is it closer to the center when compared with circumference? That's his question here. Yes, it will be closer to the center as long as it is the black circle. Therefore, all right, how do you count how many instances are there? It's an area. Therefore, what is you are trying to say? Area of inner circle. All right, inner circle. Area of inner circle. All right, divided by area of the outer circle, because when you put the point, you can put anywhere in the circle. Area of the outer circle, that is the required probability. All right, that is a probability required. Probability required is nothing but area of the inner circle, because if the point is within the inner circle, then it is closer to the circumference, then it is closer to the center, divided by area of the outer circle. Why? Because the point you can pick anywhere in the circle. You can pick that point anywhere in the circle. Why you should pick a point from inside only, inside the black circle? You can pick anywhere. Therefore, what is the area of the inner circle? Pi x square. Pi x square. Hey, what is the area of the outer circle? Pi 2x whole square. R value is given here. R values I have already mentioned. Therefore, what is it going to be? 1 divided by 4. That's the answer. Answer to this question is going to be 1 divided by 4. All right, 1 divided by 4 is the answer, not 1 by 2. Areas. Right now it is the areas. Okay, let's do one more question here and then we'll stop with that. Let's do one question and then we'll stop with this. Okay, think about this. You take 30 seconds just to think. Quickly think about this. 30 seconds you think. Think about it for 30 seconds. Okay, if you are not very familiar with inequality, then you fumble doing this question. Take quadratic equation. Think about this as x square minus 5x plus 6 is equal to 0. Forget that less than or equal to 0. Here what is given to be less than or equal to 0. Take it as equal to 0. That's fine. Solve this quadratic. Solve this quadratic. You will say that this is x minus 2, x minus 3 is equal to 0. Right? Therefore, x is equal to 2 or x is equal to 3. Fine. Come to the number line, friends. This is a number line. You have minus 1, you have 0, you have 1, you have 2, 3, likewise 4, 5, 6, 7, 8, 9 and 10. Okay, I took up to 10. You can write 11 also, not a problem. Right, but the point is 10 is good enough for us. Right, 10, 11 and so on. Okay, so now what is saying here? X can take values from 1 to 10. Does not mean that it takes 1, 2, 3. It can take, all right, now it can take root 2 also, because root 2 lies between 1 and 2, any rational number. All right, it can take 1.9999 dot dot dot, which means it can take that recurring decimal number. That is also fine. All right, it can take that value also. All right, now all these values are possible. Anything it can take. That's my point. It can take root 3 also. Yeah, it can take root 3 also. It can take 2 plus root 3 also. Somewhere here will be, all right, now 2, all right, now 2 plus, somewhere here will be 2 plus root 3. Here will be a value called 2 plus root 3. Yeah, 2 plus root 3 is also fine. So all these values it can take. Now therefore, now look at this. What is in favor? What is in favor is anything on this green line. All right, anything 1 onwards, 1 onwards, wherever, all right, now up to 10. That is what the values x can take. X can take. Okay, what is this here on the number line? How many units is this? 9 units. 1 up to 10 is 9 units. Think about this. Measure that, take a measuring tape. All right, this is the scale. 1 to 10. That's what he said. X can take values from 1 to 10, which means you are trying to say in the denominator that x can take 9 units. X can take 9 units. What is in the numerator? Find the probability that x satisfies this. X satisfies this. All right, now if it is a equation, if it is the equation here, all right, if it is a equation equal to 0, if it is equation, then it is 2 and 3 critical points. 2 and 3, only 2 points. 2 and 3, because it's an inequality less than 0, which means all the points which lie between 2 and 3, all the points which lie between 2 and 3. That's the difference between an equation and inequality. Equation means what? X is equal to 2 and x is equal to 3. But the point here is, hey man, it is less than, or it less than or equal to inequality here. I'll talk more about inequalities in the inequalities chapter. Try and recall just from your high school thing already in that inequality means what? Inequality is a range, equation is a point, equations are points. X square minus 5x plus 6 is equal to 0 simply gives you points, it gives you 2 points. Inequality gives you what? The range of values. It does not give you some points there, 2 points, 3 points. No, it gives you range. There are so many points there. All right, now therefore you are talking about what? All the values between 2 and 3. All the values between 2 and 3 critical points. 2 is a critical point, 3 is a critical point, not just 2 points. All the values between 2 and 3. How many units is this length? 1 unit. 1 unit. 1 unit is in your favor. 1 unit is in your favor out of 9 units. That's your answer. That's your answer. Answer to this question is 1 by 9, because 1 unit is in your favor out of 9 units. Therefore, answer to the given question is 1 by 9. See, this is a continuous probability, not a discrete. Not a discrete. If you make it discrete, you will say that, hey, 2 and 3, okay, 2 values I got, divided by 1 to 10, okay, 10 values. You will get some answer called 1 by 5. That's wrong. That's not. You are making it discrete. X can take anything, rational, irrational, anything on the number line between 1 and 10 it can take. But he's saying that what is the chances that it will take the values lying between 2 and 3. Therefore, 1 unit is in favor out of 9 units. I hope all of you learned about the probability. I will stop here. So I gave sufficient inputs about the probability, all types, maybe 1 or 2 minor types I would have left here. Otherwise, the basic perspective, I gave all types of inputs on probability. All you got to do is you got to solve about 50 questions. You got to solve about 50 questions on probability of various difficulty levels and various varieties as well. All varieties I covered, you just have to hit sometimes a depth. All right, because of want of time, I will not be able to take you much deeper. All right, that's the want of time. Because if I start the process in the depth, then you will miss out on the concepts. Right? I have to make a trade-off somewhere. All right, now at times I hit the depth, but I ensure that the entire breadth is kind of covered. Right? Yeah, do about 50 questions, about 40-50 questions. If you do on probability, it would be great. Now coming to the exam perspective, in CAT you generally don't find, off late, if you look at the last decade, already for last decade, if you see last 10 years, there were hardly any questions on probability. You can count on your fingers, maybe 2, 3, 4 kind of. But if you look at any other exam, all right, now be it like any other exam, it could be SNAP, it could be NMAT, it could be ZAT, or it could be IFT, you will find sufficient number of questions on probability. I don't know. I don't know why CAT is not asking the questions on probability in the last 1 decade. So be it. But you be prepared, because what if this year they turn around and say that I'll ask 2 questions on probability? Be prepared on that. But other exams anyway ask, or anyway give a preference to the probability. There are questions on probability in every other management entrance exam that you write. Here we go, friends. I will see you again in my next video. Bye till then. Stay blessed.